Let's discuss Unit 1 solutions. There are m points on one straight line AB and n points on another straight line AC, none of them being A. How many triangles can be formed with these points as vertices? They have given two straight lines, naming them as AB and AC. So let's take this to be AB. We'll take AC from the same point of A. There are many points here and the total number of points in this line will be M. So let's take this as M1, M2. Points will be from 1 to M. And if you take the other line AC, there are n number of points. We'll name them as N1, N2. So the count will be 1 to N. Now the question is, how many triangles can be formed with these points as vertices? If you take 2 points from AC and 1 point from AB, you can form a triangle here. And when you take 2 points from AB and 1 point from AC, you can form a triangle here. A triangle can be formed by the first way is I have to choose 2 points from AC and 1 point from AB. So the first kind of triangle that we have just seen. And the second point will be 2 points from AB and 1 point from AC, the second one. We have to apply combination here. The reason is only when I have the number of ways to form a triangle, I can finally count the number of triangles. So in this aspect, 1 will be written as there are totally n number of points in the line AC. So n points on AC and I have to select 2 points, which will be NC2. 1 point from AB will be there are m number of points on AB and I have to choose 1 point. This can be represented as MC1. So NC2 is from the line AC and MC1 is from the line AB. Now how do I actually represent this first point will be NC2 into MC1. This will be the first set. And the second set, 2 points from AB. So this can be written as AB will have m number of points. So MC2 into 1 point from AC. This will be NC1. The number of triangles will be the sum of 1 and 2. 1 can be written as NC2 into MC1 plus 2 can be written as MC2 into NC1. NCR is equal to n factorial divided by r factorial into n minus r factorial. Now n will be equal to n and r will be equal to 2. So this is n factorial divided by r factorial is 2 factorial, n minus 2 factorial into m factorial divided by 1 factorial into m minus 1 factorial plus MC2 will be m factorial divided by 2 factorial into m minus 2 factorial into NC1 will be n factorial divided by 1 factorial into n minus 1 factorial. So we will solve this separately so that it will be clear for you. Now let's see how to write this n factorial. This can be written as n into n minus 1 into n minus 2 factorial. 2 factorial and n minus 2 factorial. So divided by 2 factorial will be 2 into 1. So it is 2 into n minus 2 factorial will stay. So I can cancel this and this will give me n into n minus 1 divided by 2. So I will just place the same here, n into n minus 1 divided by 2. Now m factorial can be expressed as m into m minus 1. Why do I expand this is just to cancel them with the denominator. So this will be 1 factorial into m minus 1 factorial. This will be 1 factorial is again 1 and we have m minus 1 factorial. I can cancel both and this will give me the value of m into m plus. m factorial divided by 2 factorial into m minus 2 factorial. This will give, so since we have m minus 2 factorial in the denominator, we will make it as m into m minus 1, m minus 2 factorial. Divided by 2 factorial will be 2 into 1, 2. Then I have m minus 2 factorial again, I cancel this, and we have m into m minus 1 by 2 into n factorial divided by 1 factorial into n minus 1 factorial. So now we will write this as n into n minus 1 factorial divided by 1 factorial is 1 into n minus 1 factorial. So I am cancelling both and bringing this to n. This will be n. Now since this is just multiplication, I can make this as m into n minus 1 divided by 2 plus same here m into m minus 1 divided by 2. Now what is common in these two parts will be m into n divided by 2. So I am bringing m into n by 2 outside. Now what will be inside is n minus 1 will be written as it is. This plus will be retained. Then I am mentioning m minus 1. So this will give me m into n divided by 2. Now this can be rewritten as m plus n, and when you add minus 1 and minus 1, we will get minus 2. So now you can find option 2 to be exactly matching with this. Option 2 will be the right answer. Next question, find the sum of all 4-digit numbers formed using the digits 1, 2, 4 and 6. They have given a formula to do this. N minus 1 factorial into sum of the given numbers into, you have to multiply with the number of ones. How many ones will be there means n number of ones will be there. Here you can take n to be the number of digits. So 1, 2, 3 and 4 digits are available here. So n is equal to 4. The sum of all digits will be 1 plus 2 plus 4 plus 6, which is equal to 10 plus 3 will be 13. So the sum of the digits will be 13. And if you have 4 digits, it means you have to use 4 number of ones here. So now taking this to the formula, I have 4 minus 1 factorial into sum of numbers will be 13 into 1, 1, 1, 1. This will give me 3 factorial into 13 into 1, 1, 1. And 3 factorial will actually expand to 3 into 2 into 1 into 13 into 4 ones. 6 into 13 will give me 78. 78 into 1000 will give me 86,658. So this will be the answer if you know the formula. So this is the usual way if you don't have any idea about the formula. Now there are 4 digits 1, 2, 4 and 6. When you want to form a 4-digit number, it can start with 1, it can start with 2, it can start with 4, it can start with 6. If you want to know how many numbers will be totally formed with these 4 digits, I have to use 4 factorial. That is 4 into 3 into 2, 12 into 2 will give me 24. There will be 24 4-digit numbers. Now let me start with 1, 2, 4, 6. I have an option to swap 6 and 4. So 1, 2, 6, 4. Now I have to swap this part. So now I will bring 4 to this side, then 2 and 6 here. Then I have 1, 4, 6, 2 here. Now I have to bring 6 to the second part. So 1, 6, 2, 4 and 1, 6, 4, 2. When I add this, I will get 8664. There are 6 4-digit numbers here. So 6 into 4 will give me 24. Now we will start with 2. I have 1, 4, 6. Swap the last two. 2, 1, 6, 4. Then bring 4 to the second place. 1, 6, 2, 4, 6, 1. 2, 6, 1, 4 and 2, 6, 4, 1. Now when we add this, we will get 14, 4, 4, 2. Now we'll write down the number starting with 4. So it is 4, 1, 2, 6. 4, 1, 6, 2. Bringing 2 to the second place, 2, 1, 6, 2, 6, 1. Bringing 6 to the second place, it is 1, 2 and then 2, 1. Adding up all this, we will get 25, 9, 9, 8. Now starting with 6. 6, 1, 2, 4. 6, 1, 4, 2. 6, 2, 1, 4. 6, 2, 4, 1. 6, 4, 1, 2. 6, 4, 2, 1. And the sum will be 37, 5, 5, 4. Adding up all these will again result in 86, 6, 5, 8. Option number 1 will be the right answer. Next question. How many integral solutions are there to x plus y plus z plus w is equal to 29, where x is greater than or equal to 1, y is greater than or equal to 2, z is greater than or equal to 3 and w is greater than or equal to 0. For integral solutions, the number of solutions to x1 plus x2 plus till xr is equal to k. For this equation, the number of solutions will be k plus r minus 1 c r minus 1. So this will give the number of solutions. How should the equation be? It will be in the form of x1 plus x2 plus xr is equal to k. So there will be r number of terms and k will be the constant in the right hand side. There are 4 variables, namely x, y, z and w. We have to change this to x1, x2 format. We will first rearrange this part. X greater than or equal to 1 can be written as x minus 1 greater than or equal to 0. I am introducing a variable called x1 which is equal to x minus 1. Now this will result in x is equal to x1 plus 1, where x1 is greater than or equal to 0. Why do I rewrite in this way? It is because I have to bring this equation to this format, only then I can apply this particular formula. Y greater than or equal to 2. This can be written as y minus 2 greater than or equal to 0. So I am just bringing the 2 this side and just making this as 0. So since I have started with x1, now the next variable will be x2. So y minus 2 will be x2. This means x2 will be greater than or equal to 0. Now how do I write y using x2 is x2 plus 2. Now z, it is greater than or equal to 3. So the same thing we are doing, z minus 3 greater than or equal to 0. I am introducing x3 here, which will be z minus 3. And now this can be written as z is equal to x3 plus 3. So obviously when we substitute x3 to z minus 3, this will mean x3 is greater than or equal to 0. So let's take the main equation here. X plus y plus z plus w is equal to 29. X can be written as x1 plus 1. Y can be written as x2 plus 2. Z can be written as x3 plus 3. Let's take this w to be x4. We'll just label it as x4 here, which is equal to 29. x1 plus x2 plus x3 plus x4 is equal to 29 minus 1, 2 and 3 will give me 6. So 29 minus 6 will result in 23. The equation will be x1 plus x2 plus x3 plus x4, which is equal to 23. This is in the form of x1 plus x2 plus xr, which is equal to k. From this you can take the value of k to be 23 and r to be 4. We will find the number of solutions. So it is k plus r minus 1, c r minus 1. So let's substitute these values here. K plus r minus 1 will be 23 plus 4 minus 1, which will give 26, and r minus 1 will give 4 minus 1, which is equal to 3. So this will be 26c3. So this is in the form of ncr. So this will be n factorial divided by r factorial into n minus r factorial. Now it is 26 factorial divided by 3 factorial into 26 minus 3 factorial. So 26 minus 3 will be 23 factorial. I will rewrite 26 factorial as 26 into 25 into 24 into 23 factorial divided by 3 factorial can be written as 3 into 2, and this will be 23 factorial. I can just cancel this. 3 8s are will be 24 and 2 4s are will be 8. 25 into 4 will give me 100 and 100 into 26 will give me 2600. Option number 2 will be the right answer. Next question. Let n denote the set of all natural numbers. R be the relation defined by a comma b r c comma d if ad into b plus c is equal to bc into a plus d. They are asking us to find whether they hold one of the properties or all the properties that exist in equivalence relation. To test for a reflexive, usually we represent a comma a that belongs to R for all a that belongs to the set A. So R refers to the relation here, and when I mention capital A, it means the set. We cannot check it with A because there are two elements involved in both the left hand side as well as the right hand side. So this can be written as let A comma B relation A comma B. This A will be the same as this A. Instead of this, I am using A comma B. Wherever C comes, I have to substitute it by A, and wherever D comes, I have to substitute by B. Now I have to put it in this form. So AB into A plus B, which is equal to BA into A plus B. Since it is multiplication, I am just converting this as A into B, A plus B. So both these sides are same, and so reflexive property is there. Now we will check for symmetric property. For symmetric, we have if A comma B belongs to R, then B comma A also belongs to R for all A comma B that belongs to the set A. So let us take it as let A comma B relation C comma D. Use the same equation here, AD into B plus C, which is equal to BC into A plus D. Now just bring left hand side to the right hand side and right hand side to the left hand side. So BC into A plus D is equal to AD into B plus C. Now just swap these two. C into B, D plus A. Both will be equal only, but we are just swapping and writing. Similarly, DA into C plus B. What will this give me is C comma D relation A comma B. If A is A comma B and B is C comma D, the swapping C comma D relation B comma A is also existing through this. So in this way we are proving it to be symmetric too. Once when you prove it is symmetric and reflexive, automatically there is only one option from the following that you can choose. So it will be definitely an equivalence relation, which means transitive property can also be proved. So before testing for transitivity, once you are sure of reflexive as well as symmetric, you can mark the answer to be option number 4. Now we will check for transitive property. This is the usual format that we give, and for this problem we are using this. Okay. So usually how will we write transitivity is if A comma B that belongs to R and B comma C that belongs to R, then automatically transitive property will say A comma C will also be in R, and this is for all A comma B comma C that belongs to A. We will have to take two sets. So let A comma B relation C comma D. This is for A and this is for B. And then we will take another set. Let C comma D relation E comma F. This is B and this is C. So let's start with this part here. A comma B or C comma D can be written as AD into B plus C equal to BC into A plus D. Now just multiply them inside. ADB plus ADC equal to BCA plus BCD. This has AB and this has AB. So just write it as ABD plus ABC. This should be written in the form of CD. This is ACD and this is BCD. Let it stay. Now bring this to one side. So AB into D minus C, which is equal to, bring this to the other side, which will give B minus A into CD. We will write this in the form of AB divided by B minus A, which is equal to CD divided by D minus C. So let's mark this to be equation number 1. We'll do the same thing for this particular relation. So instead of A, B, we have CD. Instead of CD, we have EF. This will result in CF into D plus E. You can work it out and see in a slow manner. I am just writing this. So wherever I have A, I will place C. Wherever I have B, I will place D. Wherever I have C, I will place E, and wherever I have D, I will place F. CFD plus CFE, which is equal to DEC plus DEF. So I'll just change this as CD in one way. So F will stay here and I will make it as EF here. And similarly it is CDE and DEF will stay as it is. So CD will be in one side, F when E comes this side it will be E, which is equal to D minus C into EF. And this can be written in the form CD by D minus C, which is equal to EF. We can name this to be second equation. From 1 and 2, what we get is, we have A into B divided by B minus A is equal to CD D minus C. So what is CD D minus C will be this one. So this will be EF divided by F minus E, which says that the right hand side has a value in my second equation with another two variables. So this will say AB divided by B minus A, which is equal to EF divided by F minus E. When you have AB divided by B minus A, what is it from? It is from A comma B. So let me have A comma B relation. EF divided by F minus E is from E comma F. So I am placing this. When we have A comma B relation C comma D and C comma D relation E comma F, transitivity will show that A comma B will be in relation with E comma F. So this is the usual A, B, this will be the B, this will be the C, and now A will be related to C. So this is how we have proved this is also transitive. So in this way we are proving it to be an equivalence relation, but you need not go for this part. So once you prove reflexive as well as symmetric, you need not check for transitiveness due to the options given like this. Next question. A is equal to 4n plus 2 where n is a natural number. B is equal to 3n where n is a natural number. Which of the following is correct for A intersection B? Now let's have the set A here. When n is equal to 1. So 4 into 1 will give me 4. 4 plus 2 will give me 6. Then n is equal to 2. 4 into 2, 8. 8 plus 2 is 10. Then 4 into 3, 12 plus 2, 14. Then 4 into 4, 16 plus 2, 18. When it is 5, it is 22. When it is 6, it is 26. When it is 7, it is 30. Next we will come to B. B, it is actually 3 into n. 3 into 1, it is 3. 3 into 2, 6. 3 into 3, 9. 3 into 4, 12. 3 into 5 15, 3 into 6 18, 3 into 7 21. We will have 3 comma 6 comma 9 comma 12 comma 15 comma 18 comma 21 comma 24 comma 27 comma 30. Now A intersection B will have 6. Intersection in the sense the element must be present in both A as well as in B. Then we have 18, then we have 30. Now what we will be doing is we have to check all these numbers and see which set is matching with A intersection B. So let's take n here, then we'll have 12n square plus 6n value here, and then we'll find it out. So for n is equal to 1, 12 plus 6 is 18. So it starts with 18 and it misses 6, so 1 will not be the answer. Then we have 24n minus 12. So 24 into 1 is 24, minus 12 is again 12. A intersection B doesn't have 12. So this is also out of the race. Then we will go with 60n plus 30. The first number itself is in 90, but the previous number 6, 18, 13 less than 90 are not found. So this will also not be there. Now we will check for 12n minus 6. So when n is equal to 1, it is 6. When n is equal to 2, 12 into 2, 24, 24 minus 6 will be 18. When n is equal to 3, it is 36 minus 6, it is 30. So 12n minus 6 has the set 6, 18, 13. So minimum the first 3 elements are taken from this particular expression. So we go with option number 4. 12n minus 6, n is a natural number, will be right for A intersection B because both have the same set of numbers. Next question, let G is equal to real number difference 0 and H is equal to minus 1 comma 1. Let them be the groups under the multiplication. Then the mapping from G to H is defined by this. What is this? Basically, we have to understand one thing. R is a set of real numbers. Real numbers in the sense you can have both positive, you can have negative, you can have 0, everything. So in short, let me give it as negative, 0 and positive numbers. We have a denotation called R star. The R without 0 is R star. What is this R without 0? When you have the set R cannot be multiplicative. They have given it is a group under multiplication. So R cannot be multiplicative in the sense when you have 0, any element multiplied with 0 will give you 0. Excluding the 0 from the real number group, we are mentioning R to be a group under multiplication. G is equal to R divided by 0. This means R difference 0. So this is not subtraction, this is actually set difference. This is a set and this is a set. When you give minus, it means it is set difference. It means R, the real number set is excluding the element 0. G is equal to R by element 0 is nothing but the real number set without 0. So let's take for an example what elements does G contain. It can have 1, 2, 3 for the positive side and it can have minus 1, minus 2, minus 3 in the negative side. H is equal to minus 1 comma 1 and this is also a group under multiplication. So H contains 2 elements minus 1 and 1. In order to prove this H group to be under multiplication, they say you have to prove closure, you have to prove identity, associativity and inverse. Once you prove all these 4 properties, they say it's a group under multiplication. I'm not getting into those proof now, but I'm just telling you why it is under multiplication. Now we'll just get on to the main part of the question. There's a mapping between G and H. In order to make it very simple, let me take this G in this format for making a map. So minus 3, minus 2, minus 1, 1, 2 and 3. And for H, we'll have it as minus 1 and 1. They have given a function, the mapping function, phi of x is equal to x divided by x mod. It means whenever you present a negative number or a positive number, it ends up positive. So when I apply this modulus to a negative number, it turns positive. When I say it is minus 1, it is 1. When I say it is 1, it is again 1. So when I say it is minus 2, it is 2. When I say it is 2, it is 2. So when I apply modulus, it automatically converts into positive. Phi of x is equal to x divided by mod of x. X is from the set of real numbers. We should not take it for 0 because they have given it is excluding 0 here. So don't take 0 for x. X is equal to 1, which implies phi of 1 is equal to 1 divided by modulus of 1 will give me 1. X is equal to 2. Phi of 2 will give me 2 divided by modulus 2, which is equal to 1. X is equal to 3. Phi of 3 will give me 3 divided by modulus of 3, which is again 1. Now just apply negative elements here. X is equal to minus 1. Phi of minus 1 is equal to minus 1 divided by modulus of minus 1, which is equal to minus 1 by 1 will give me minus 1. Can you understand? Actually, if you don't have modulus, you can just cancel them and say it is 1. But since you have modulus in the denominator, you have to convert it into positive number and then take the division. Now when x is equal to minus 2, phi of minus 2 is equal to minus 2 divided by minus 2 under modulus, and minus 2 by 2 will give again minus 1. Then x is equal to minus 3. Till 3 we can go for both positive and negative to check this. So phi of minus 3 will be minus 3 divided by modulus of minus 3, which is equal to minus 3 divided by 3 and again minus 1. Can you find the solution here? Whatever number you have, it ends up with either 1 or minus 1. Now we will just do a mapping here. All the negative numbers are mapping to minus 1. All the positive numbers are mapping to plus 1. Now we have to find what kind of group it is, whether it is a homomorphism or whether it is one-to-one or on-to, we have to find it. Now let's understand what is homomorphism. When you have a mapping from G to H, this particular phi is homomorphism if phi of G into H is equal to phi of G and phi of H. You would have already come across certain questions that will ask you to apply homomorphism in some kind of equations. So in that you will combine both the equations and give them as a mapping function. The similar way it says once there is a mapping from one group to another group, there is a homomorphism. So not a homomorphism will be out of the option. So now we have to check whether it is on-to or one-to-one or only a homomorphism. Now we will see what is one-to-one. You have A and B here. You have 3 points here and you have 3 points here. When there is a mapping from A to B, B cannot have more than one A. You can have another element here, maybe the fourth element. I can map this here, I can map this here, it goes on. I can have elements left in the B set, but all the elements in A will be used. The thing is, B cannot have more than one A. In this case, they say this is injective. In onto homomorphism or onto mapping, there are two sets named A and B. I have 4 points here, 1, 2, 3, 4, and I have 3 points here. All B elements are used. All B elements in the sense the mapping can be 1 here and 2 and 3. Both the points can map to one element of B and this can be mapped to the last element of B. For better clarity, I am marking the point here. Okay. So here some unused B elements will be there, but here all the B elements will be used, and this is called as surjective. Injective is one-to-one and surjective is onto. There is a term bijective, which means it is both injective as well as surjective. This means the A to B mapping will be perfect. Now in this case, we are just using a sample of the real number set. So the mapping of elements is like it is getting mapped only to 2 elements here. Let's take this to be the A set and this to be the B set. You have more number of G elements, and whatever elements you have, everything is going to get mapped only to these 2 elements. You don't have any B element left out. So one-to-one will not be there because all the B elements are used. You can take this to be onto homomorphism. This is not one-to-one. and an homomorphism will be out of the race. Another thing you can take from this is, you can see 1A mapping to one element in 1 to 1. Here multiple A's are mapping to one element of B. So multiple elements in the sense -3, -2, -1 are multiple elements mapping to -1 in H. Similarly 1, 2, 3 multiple elements are mapping to 1. So this perfectly sits in onto homomorphism. That's why we are marking option 3 to be the right answer. Next question. Let Z denote the group of all integers under addition. Then the number of all automorphisms of Z is. Integers under addition, this is represented as Z plus. In the previous question, we saw a word about bijective, and in the noun form of bijective is bijection. So whenever the homomorphism is bijection, or whenever it is bijective, when it exhibits both injection as well as surjection, it is called isomorphism. Automorphism is isomorphism from the group to itself. In other words, we can say a bijective map that preserves group structure. Z plus, the set of all integers under addition. If you take the properties for this, you can take the closure property. When you add two positive numbers, say A plus B, the sum will again be positive. Then if you take associativity, so if you say it is A plus B plus C, this can be A plus B plus C. So associativity is also there. Then if you take the identity one, so A plus 0 or 0 plus A, both will be ending up with A. And then for inverse, we have A plus minus A or minus A plus A, both will result in 0. So this is closure, this is associativity, this is identity, and this is inverse. So it has all the four properties. When you take the structure of Z plus group, this group is an infinite cyclic group generated by integer 1. If you want to get the other integers of the group, it can be done using 1. Example, if you have 1, it is actually 1. When you want 2, you can just add up another 1. When you want 3, you can just add 3 ones. When you want 10, you can add up to 10 ones. So every integer can be expressed as a sum of 1 or their inverses. Maybe if you take -2, then it is -1 and -1. So in one or the other way, only 1 will be involved there. The number of ones will decide what integer it will be. So this is the structure of Z plus group. Now we'll get on to the question. The number of all automorphism. What kind of automorphism it has? First, it has identity automorphism. It's a map that sends each integer to itself. And the next one is negation automorphism. It means the map that sends each integer to its negation. If A is there, it will be sending it to -A. This map is bijective and it preserves the group structure, and it is also an isomorphism because there is one-to-one correspondent between two sets that preserves binary relationship between set elements. So even when you add, it will end up with the same group of Z plus. In this way, we have two automorphisms in Z plus. If map sends integer 1 to A, it must send n. In this case, n will be 10. It means there will be 10 ones added together to give the integer 10 for the purpose of sum of n ones for any n. So there are no other integer to satisfy this, and so no other automorphism, because whatever happens will happen between 1 and the number of ones. So in this way they say it has two automorphisms. One is identity and another one is negation. We mark the number of all automorphisms to be option number 2, 2. Next question. Let R is equal to X that belongs to set of natural numbers. X is a multiple of 3 and X is less than or equal to 100. S is equal to X is a multiple of 5 and X less than 100. So here the limit will be 1 to 100 and it must be in the multiple of 3, and S will be 1 to 99 and a multiple of 5. Let's write R here. 3, 6, 9, 12. Since it's a multiple of 3, I can have 90, 93, 96, 99. Even though it has 100, I cannot take 100 because it's not a multiple of 3. When you take S, you have to end it up with 99. So let's have 5, 10, 15. Then it goes on till 85, 90, 95. It ends up here. What is the number of elements in R intersection S and S intersection R? Let's have R intersection S. When you take multiple of 3 and multiple of 5, both are actually prime numbers. When you want to take the intersection, you have to take it in the form of 3 into 5. In fact, they will say if you take the LCM of 3 and 5, it will end up in 15. So when you want to take the intersection, in 3 or in 5, you have to see the multiples of 15. So here you have 15. So I can take 15. Anything below 15 you don't have. You don't have 5, you don't have 10 in 3. So if you take 20, it won't be there. 25, it won't. 30, it will be there because 10 3s are 30 and 5 6 are 30. So 30 will be there. Similarly, 45. So 15 3s are 45 and 5 9s are 45. Then we have 60. 20 into 3 60 and 12 into 5 is 60. Then we have 75. Then we have 90. We cannot go more than this because the next number will be 105. The limit here it is 100 and here it is 99. So we are stopping with 90. How many numbers do we have? We have 6 elements. This is for R intersection S. Intersection is commutative. So R intersection S will be equal to S intersection R. R intersection S has 6 numbers and S intersection R has 6 numbers. The question is R intersection S into S intersection R. So 6 into 6 will give 36 elements. So option number 1 will be the right answer. Next question, consider the following statements. Let's have a general statement here. Any set with the given operations, if it follows closure property, it is called as algebraic structure. When it follows closure property and associative property, it is a semi-group. When it follows closure, associative and has unique identity element, it is called a monoid. When it has closure, associativity, unique identity element and then inverse for each element, it is called as a group. When these properties closure, associativity, identity, inverse hold as well as they follow commutative law, it is called as abelian group. Now let's see the statements. The identity is unique in any monoid. Only when you have unique identity element, it is called a monoid. So A is true. A monoid is a group if there exists inverse of each element of monoid. So when you have closure, associativity, identity and inverse property, it is called a group. So a monoid is a group when there is inverse. B is also right. Semigroup has closure, associative and identity properties. When you have closure and associative property, it is a semigroup. So it has both these properties. Once identity comes inside, it becomes a monoid. So C is not correct. When you have all these properties, this becomes a monoid. If you don't have any idea about quasi-group, let's solve with this. When you exclude C, all the 3 options will be removed. So option number 1. A, B and D only will be the right answer. So from this we can understand quasi-group as closure property is true. But what is actually a quasi-group is it resembles a group in the sense that division is possible. Since division is possible, it has cancellation property. Let me just tell you an example for this cancellation property. If AB is equal to AC, let me cancel A and A. This will say that B is equal to C. Only when it satisfies the closure property, it comes under the algebraic structure. So quasi-group as closure property will be obviously true. Next question. Match list 1 with list 2. What is PERT? Program evaluation and review technique. It is used for unpredictable, non-repetitive activities. PRT is used for non-repetitive jobs. Jobs or activities both mean the same. So A is mapping to 1. Two options are ruled out. Next we will go for CPM. CPM is critical path method. CPM is used for predictable and repetitive tasks. CPM is mapping to used for repetitive jobs. C2. Actually, if you can see, C and D are mapping to the same option. So mostly you might not have third option. Let's check. Then they have given two times, optimistic time and pessimistic time. So optimistic time means you can just remind the term to optimal. Anything that is being completed in a short time. So in this aspect we are mapping B to 3. The shortest possible time to complete the activity if all goes well. Pessimistic time. The longest time that an activity takes. So D is mapping to 4. So as I told, third one is ruled out. Option number 4 will be the right answer. So with this we are completing Unit 1 questions. Let's discuss Unit 2 solutions. A processor chip is used for application in which 30% of execution time is spent on floating point addition. For the new model of the processor, the design team has come up with redesigning the floating point adder to make it twice as fast. What will be possible maximum speed up by this redesign? There is a law to calculate the speed up process. The law's name will be Amdahl's law. This is used to calculate expected system improvement when parts of the system are improved. Redesigning the floating point adder is the part of the system that needs improvement because we have to make it twice as fast. Speed up is equal to 1 divided by 1 minus f plus f by n. What is this f? This is the enhanced fraction and n will be the speed up factor for enhanced fraction. Here the enhanced fraction will be 30% of execution time. So we assign 30% to f. 30% can be written as 30 divided by 100, which is equal to 0.3, and n is equal to the speed up factor. So how much speed they have mentioned here in the question is make it twice as fast. So whatever the speed is, we have to just make it twice. So twice as fast can be represented using the number 2. So we will apply these values in speed up formula. Speed up is equal to 1 divided by 1 minus 0.3 plus 0.3 divided by 2. 1 minus 0.3 will give 0.7. 0.3 divided by 2 will give 0.15. 0.7 plus 0.15 will give 0.85. You will end up with 1.1765. This can be approximately equivalent to 1.18. Option number 3 will be the right answer. Next question. What is the 4 plus 4 fit binary fixed point equivalent of minus 3.72 in decimal format? This is in decimal and they are asking in binary format. Here you have 4 bits before the point and 4 bits after the point. So that's why they have asked in 4 plus 4 fit form. What is the actual process of finding the negation of some floating point number? We will see the process first. For this floating point or the decimal point, if there is a number, first we have to convert decimal to binary. Next we have to take ones complement of the answer, and the third step will be we have to add 1 to the answer of the second step. Ones complement is you have to change all your zeros to ones and ones to zeros. In 8421 format, I will have 0011. So 0011 will be equal to 3 in decimal. If you see all the 4 options, almost 1, 2 and 4 all have the representation of 3. But once you negate this number, you have to apply ones complement. At this stage itself, this 3 will become 1100. So without referring this 0.72 part, we can easily say option 1, 2 and 4 are wrong. Option 3 will be the right answer. Now we will just solve it using the steps written here. The first step is to convert decimal to binary. So here's a whole number 3 and we have a point here. 3 in decimal will be converted to 0011 in binary. Then 0.72 in decimal. So how will you convert this into binary is you have to keep multiplying it by 2. Say for example 0.72 into 2. This will give 1.44. Now this digit before the point will be mentioned here. Now you have to take this 0.44 alone. You have to take this in the answer part and this for further multiplication. So I'll just take 0.44 into 2. It is 0.88. Now we'll mention the 0 here. Then 0.88 into 2 will give 1.76. Again mention 1 here. 0.76 into 2 will give 1.52. So mention the 1 here. 0.52 into 2. Make sure you go for 6 or 7 digits of binary value. Though they have asked only 4 digits after the point, we'll just go for some 6 or 7 values. So 0.52 into 2 will give 1.04. Again we have 1. 0.04 into 2 will give 0.08. 0.08 into 2 will give 0.16. So we have 2 zeros here. I think we can stop with this. Now the value of 3.72 in decimal will be 0011, 101110 and it goes on in binary. Actually you cannot end this binary form of 0.72 because after some iterations you will have 0.88 again, then the same thing will come around again. So we are stopping with this. Now this will be the first step. The second step will be applying 1's complement. So 0011 101100. Just apply 1's complement here. It means I have to change zeros to ones and ones to zeros. 1100 010011. Now I have to add 1 to this. So 1100.01. Let's stop with 5 digits here and just adding 1. 0 plus 1 will give me 1. 0010. Then we have 0011. This will be the binary fixed point equivalent of minus 3.72. This is equivalent in option number 3. Making it for 4 plus 4 binary fixed point, this will be 1100 is 4 bits. We just take only the first 4 bits here. So 0100. Why I am stopping with the 5th bit here is only this will be counted for the end result for this question. Actually, you cannot take only 4 bits here and add 1. This will ultimately disturb this position here. That's why we are taking extra bits after 4 and then adding 1 there. Since 0.72 runs long, adding 1 to 1's complement will not affect first 4 bits. For 3.72, this will be the answer and you can find this answer almost equivalent in option number 4. Option number 1 will be 3.75. Option number 2 will be 3.625. This is actually in positive form and this is in negative form. Next question. 256 MB dynamic RAM is organized as a 32M into 8 memory externally and as a 16K into 16K square array internally. Just take a square. You have 16K this side and 16K this side. This is externally and this is internally. Each row must be refreshed at least once every 50 milliseconds to forestall loss of data. Forestall in the sense you can take this as prevent, in order to prevent loss of data. Refreshing one row takes 100 nanoseconds. What fraction of the total memory bandwidth is lost to refresh cycles? Rows are refreshed once in 50 milliseconds. Refreshing one row takes 100 nanoseconds. So just consider them to be an array. You can understand the row and the column format. So this will be 1, 2, 3, 4 columns, and this will be the rows. So you have 16k rows. So refreshing 16k rows will take 16k into 100. So this k can be taken as 1024 into 100 nanoseconds. And here 16 into 1024 will give 16384 into 100 nanoseconds, which is equal to 1638400 nanoseconds. Since they have given each row must be refreshed at least once every 50 milliseconds, we have to convert this nanoseconds to milliseconds. Nanosecond to millisecond conversion will be approximately equivalent to 1.6384. Nano is 10 power 9 and milliseconds will be 10 power 3. Ultimately, you have to reduce to 10 power minus 6. So you have to move 6 positions. 1, 2, 3, 4, 5, 6. That's why I have placed the point in between 1 and 6. So why I am moving 6 position is because I am converting nano to milliseconds. So minus 9 plus 3 will give me minus 6. That's why it is moving in this direction. Refreshing process of 16k rows will take 1.64 milliseconds. So I am just approximating it, 384 to 4. What fraction of total memory bandwidth is lost to refresh cycles? So loss of 1.64 milliseconds every 50 milliseconds. This will give 1.64 divided by 50. This will give 0.0328. And since they have represented the answer in percentage, we are just multiplying this by 100, and this will give 3.28 percentage, which is approximately equivalent to 3.3 percentage. This much will be lost. So option number 2, 3.3% will be the right answer. So this diagram is actually incomplete here. Let me give you in short. This is 16k this side and 16k this side. We'll have a row decoder here. We have a row buffer here, and we have a column multiplexer. This is for data out. This was the glimpse of the diagram that I have got. Next question. Let the symbol denote XOR operation. Let 1 and 0 denote the binary constants, and F is the Boolean expression over two variables P and Q. Let's take P and Q as a truth table here. 0, 0, 0, 1, 1, 0, 1, 1. What is P XOR Q? Whenever we have same input, we get 0. Whenever we have different input, we get 1. This is the case of XOR. So the condition for 0 will be P into Q, P naught into Q naught. And to get 1, we will have P dash Q plus PQ dash. And this will be XOR, and this will be negating the XOR. Before getting into this question, we will find this. P XOR Q is fine. You have something called 1 XOR P and Q XOR 0. So what happens when I XOR something with 0 or 1? So let's take P XOR 0. This is equal to find the XOR, I have to use this format. So here it is P for me and 0 will be Q. P bar 0 plus P into 0 bar. This will give anything into 0 is 0 plus P into 1. This will give P. When I XOR 0 with a variable, I get the variable. So P plus 0 will give me P. 0 plus P will give me P. Q plus 0 will give me Q. You have XOR with 1. So what is P XOR 1? So P bar into 1 plus P into 1 bar. P bar into 1 will give P bar plus P into 1 bar is 0. So the complement of 1 will be 0. Anything with 0 is 0. So we will end up with P bar. So P XOR 1 or 1 XOR P will give negation of P. The same thing applies for Q. XOR is commutative and associative. And there is also another rule. If you take an element P and if I do XOR operation with P again, this will result in 0. How does this happen? A small proof. So P XOR P will be P into P bar plus P bar into P. 1 into 0 or 0 into 1 will give me 0. This way we are bringing 0 here. So always remember, any variable that is in XOR operation with the same variable will end up with 0. Now let's solve this. 1 XOR P will result in P bar. XOR this P XOR Q will stay. XOR P XOR Q will stay the same. This XOR here and Q XOR 0 will give Q. Let A is equal to P XOR Q. So how will you change this is A XOR A. What is A XOR A? It is 0. So the whole expression here will become 0. So P dash XOR 0 XOR Q. This 0 is because we are taking let A is equal to P XOR Q. Any variable that has XOR operation with the same variable will end up in 0. Now anything with 0 will give the same variable. So this will be P bar XOR Q. First we have to take this to be P and take this to be Q. P bar will be P bar Q plus P bar will stay and then you are negating Q. So I have two negation here. I am cancelling it and bringing to PQ plus P bar Q bar. It is in the form of negation of XOR. So now I can put this as P XOR Q and whole negation will be applied. It is because we are getting the results of 0 part. Option number 4 will be the right answer. All these things must be in mind before you start this problem. Next question, match list 1 with list 2. What is A delta B? Let me represent it using a Venn diagram. So take this to be A and take this to be B. Except the intersection part of AB, delta covers everything. It has everything except A intersection B. You have two formulas. The first formula will be A union B, difference A intersection B. So I take the whole of A union B and I am just removing the intersection part alone. That gives me A delta B. The other formula to represent this will be B minus A union A minus B, or A minus B union B minus A. B minus A will give everything in B but it will exclude only A, and A minus B will include everything in A but it will exclude B part alone. The A intersection B part will be excluded in total. If you find option number 3, A minus B union B minus A, this formula is given here. So A is mapping to option number 3. A with third option is option number 1. So this will be the right answer. So let's work out B. A minus B union C. Now we have to apply this set difference operation to the variables inside. So this will result in A minus B, A minus C. So what will be the operator in between is this union will become intersection. So B will be mapping to 2. Let's take C. A difference B intersection C. The same thing. A minus B will be there. A minus C will be there. Instead of intersection, we will have union. So first option will be for C. Then D. A intersection B minus C will give A intersection B, A intersection C, and we'll apply the difference here. So this is equal to option number 4. Next question. This is actually based on the topic virtual memory. These questions can also be placed in operating system unit 5. So for video length purpose, I am just placing it in computer system architecture unit. Now let's get into the question. Consider the following program fragment that deals with the table T with 17 rows and 1024 columns. So the number of elements that it has will be 1024 into 17. It is 17408. These many elements are present. Computing an average for each column and printing into screen. So they have given two for loops. One is counting rows and another is counting the columns. Since columns are given a number of 1024, the first loop mentioned here counts the columns and the second loop is counting the rows and it is printing to screen. I is row index as I have already told and J is column index. So what does this program do is it is just starting with J loop. It is initializing a variable called temp with 0. Then I have an inner loop with I 0 to 16. So 0 to 1023 will give 1024 columns and 0 to 16 will give 17 rows. You know the index will be starting from zeros in arrays. So they have used the same pattern here. Now there is a simple calculation. Temp is equal to temp plus, that is 0 plus the element from the table T. If we want to access some element, we have to access the particular row and the particular column. So this is T of I and J. After accessing the element, so here they have given computing an average for each column. So a print statement is here. Table with index ij and temp are 32-bit floating point values and memory is word addressable. The temporary variable temp is kept in a processor register, so access to temp does not involve a memory reference. You need not access temp from the main memory. The main memory is page and holds 16 pages of size 1024 words. So the number of pages will be 16. Words per page will be 1024. The page replacement policy is least recently used. If T is stored in the virtual address space in row major format, whenever we want to store a table, there are two ways of storing it. One is in row major order and the other is column major order. So the subsequent questions will have column major order. I will explain column part in that question. This part is row major format. So when you take a table with row major format, you will have something like this. This is row 0, 1, 2 and this is column 0, 1, 2. When I say it is 0, 0, 0, 1, 0, 2, the axis will be going row wise. So if I take a row, I will access everything and then I will go to the next row. Column wise axis will be, I will access the complete column and then I will go for the next. This is in general about a row major arrangement and a column major arrangement. Now the first question is how many page faults will be encountered for j is equal to 0 to 1023 and for I is equal to 0 to 16. So if you take T, this 0 will stay. This is I and this is j. This j will stay and the ith index will have the change 0, 1, 2, 3, 4 and everything will have 0th column here. It means I am accessing it in this way. The first element will be 0, 0. The second element will be 1, 0. Here every row takes one page. One row has 1024 columns. It means 1024 elements are present in one page because a page has 1024 words and the memory is word addressable. All these are information in the question. Since every row takes one page, one word in one page is printed. So if you take first 0, 0, it is printed in 0th page. 1, 0 is printed in first page. 2, comma 0 is printed in second page. Whenever I access a new row, it means I'm accessing a new page. So how many times I access the pages? For one column, I am accessing 17 pages. What about 1024 columns? I'll be accessing 17 into 1024 times. So for printing content from one column, I am referring 17 pages. Why they have mentioned least recently used is, if I take page 0, am I printing everything from page 0? No. When I take page 1, am I printing everything from page 1? No. For printing one element, I refer one page. So for printing 17,408 elements, I have to reference every page every time. It means the number of page faults will be 17 into 1024, which is equal to 17,408. Option number 2 will be the right answer. So let me again tell you, take this to be word and take this to be the page. 0th word in 0th page, first word in first page, second word in second page, it goes on. So after completing 16 pages, then I have to start with 0, 1, 2 again. And the word will be continuing till 1024. So least recently used means whatever page I referred before, that page has to be referred again. This loop does not give that possibility. For that reason, I am accessing a new page every time I access a element. So here accessing this table is alone taken into consideration because temp is kept in a processor register. It does not involve a memory reference. I am considering only the table access. I take the first column, I refer all pages. I take the second column, I refer all pages. So for 1024 column into 17 pages, this is the calculation that we do. So for every element, I am accessing every page. If I place the element in the same page, then the page fault will be reduced. If I don't access the same page, then the page fault will be increasing. I hope you understand this. Maybe the subsequent questions will make it clear. Next question, what is the main memory hit ratio? First, let's understand what is hit ratio. Now let's take least recently used. Let me take a frame size of 3. Let's take 2, 1, 2, 3, 2. So first I am placing 2. So this is a page fault. Then I am referring 1. So this is a page fault. This is how we will be calculating in page replacement policy, right? Now I have 2 again. I will not place it, but I will take the same reference. Now again I will be referring a new page. So 2, 1, 3. So here there is a fault. When I am referring the same page that is already in the memory, it is called as hit. Hit means the page is referenced from the main memory. If there is a page fault, then I am taking it from some other place. I mean, like the secondary memory has to load it in the main memory and then it has to be referenced. Whenever there is no page fault, there will be a hit. This is hit in context of main memory. What is generally hit ratio? The number of hits divided by the number of hits plus miss. The hits will be the number of references made. So this miss will be the page fault. So hits divided by hits plus the page faults. So overall, how many hits plus misses will be there is, you have to take the overall count. All the elements will take 17,408. And how many hits are there? Every time I am referring a new page and still it is in row major format. So for each row, I take one page and so there are 17,408 page faults. All the elements are using new page. In this case, the number of hits will be equal to 0. I mean no page is referenced again. In case if there is a hit, then there will not be any page fault. Fault is bringing them inside and hit is using what is already inside. Here the false will be 17408 along with 0 plus 17408. This will give 0 by 17408, which is again 0. 0 by anything is 0. Whenever the CPU references the memory, we call it as hit, and whenever a page is brought to the main memory, we call it as fault. That's why I gave you this example. Again, just we'll continue the same example. So 2, 1, 3, I am referring to again, I am not bringing any new page. So this is again a hit. So regarding these 5, I can say the hits is equal to 2 and the false is equal to 3. So the ratio will be 2 divided by 5. This is how we will be calculating. So the same case I am applying. There are 17408 page faults and there are 0 hits for 17408 elements. So when there are 0 hits, 0 by anything will give me 0. So what is the main memory hit ratio? Option number 1, 0 will be the right answer. In row major format, there are 17408 page faults for 17408 elements. In this case, there are no hits. Therefore, hits is equal to 0. That's why hit ratio is 0. Next question. Consider that T is stored in column major format. How many page faults will be encountered? For I is equal to 0 to 16, temp is equal to 0. For j is equal to 0 to 1023, and then the access is taking place and printing is taking place. We usually create array keeping for row index and for column index, but they have given in for column index to row index. Now column major format, you have to just swap column part and row part in the loop. So I am placing the row part here and the column part here. So let's take the T is stored in column major format is this part. How many page faults will be encountered? So for I is equal to 0, whenever I is equal to 0, how many elements can be accessed is 1024 elements can be accessed. So when I is equal to 60, 1024 elements can be accessed because the inner loop has the column count and the outer loop is having row count. As we already saw, each row takes one page. How many pages are referenced here is 17 pages are referenced. When I take my first page, I take 1024 elements. When I refer second page, 1024. Similarly, in my 17th page, I take the last 1024 elements. T of 0, 0, 0, 1 and then this is 1, 0, 1, 23. So in this way, this is row 1. In other way, I can say this is page 1. So keeping page 1 in memory, I can access 1024 elements. Keeping page 2 in memory, I can access 1024 elements. So only for 0, 0, I am accessing page 1. From 0, 1 to 0, 1023, I am just using hits of page 1. In least recently used, I gave an example. When there is no page fault, I said there will be hits. So here one page fault occurs and 1023 hits occur. When I bring in the first page to the memory, it is page fault. When I refer it again and again for the rest of the element, it becomes hits. If T is stored in column major format, how many page faults will be there is, the number of rows will be the number of pages here. So totally 17 rows means 17 page faults will occur. Option number 4, 17 will be the right answer. So for all 17408 elements, we need only 17 page faults, because every page is having 1024 elements. When the outer loop is column, page faults are more. When the outer loop is row, page faults are less. Next question. Consider again that T is stored in column major format. What is the main memory hit ratio? In column measure, I said first we'll have ith row from 0 to 16. Then we have inner loop jth column from 0 to 1023. I told you the page fault for page 1 will be 1 and the hits will be 1023. This means for 1024 elements, I have one page fault and 1023 hits. For this alone, I can calculate like hits is equal to 1023 divided by hits plus false or hits plus miss, whatever you understand. So 1023 divided by 1023 plus 1, which is equal to 1023 divided by 1024. This will give me 0.999, and when you multiply it by 100 to bring it to percentage, you will get 99.9%. Option number 4 will be the right answer. If you want to take it in a detailed way. For 1024 elements, I said there are one page fault with 1023 hits. This is in the case of one row. What happens when there are 17 rows? So we'll say 17 page faults plus 17 into 1023 hits will be there. So in this case I can say hit ratio is equal to the number of hits will be 17 into 1023 divided by, so 17 into 1023 will be here plus page faults. So 17 into 1. Keep the 17 in the numerator as it is and bring the 17 outside. So there are 17 page faults. Instead of keeping it as 17, I am just marking it as 17 into 1. Or you can just place it as 17. So cancelling the 17, you will again end up with 1023 by 1024. This is the actual way of mentioning it. With just one page, I have mentioned like this. For one row count and for 17 rows, I have explained in this way. Certain people can also do this in other way. For accessing 1023 elements in 17 rows divided by accessing 1024 elements in 17 rows. This ratio will be 17391 divided by 17408. So this is another way of writing. Whatever you write, you will end up with 99.9%. Why I am giving way 1, way 2 or way 3 is all these three explanations are same. So first I am calculating only for one particular page. I am just separating the page fault and hits and doing this calculation. I have done this way. To consider all the 17 pages together, I did this way, and to do it based on the elements, like the hits will be the number of elements accessed, right? So out of 17408, if you take 17 elements, because for the first page fault that element will be accessed, if you take, you will end up with 17391. So 17391 elements are accessed from the memory out of 17408 total elements. The next question, what is the fault ratio of row major to column major arrangements? The page fault we had during row major, the 91st question had 17408. How did we end up with this 17408? It was 17 into 1024. How many page faults were there in column major? That is the answer of 93rd question. It was 17. Now they are asking the fault ratio of row major to column major. So just place row major is to column major. Now you can mention as 17 into 1024 is to 17. I am just placing this way. So 17 gets cancelled. So 1024 is to 1. Option number 1 will be the right answer. When you have lots of time, you divide 17,408 by 17 and bring to 1024. It's your choice. With this, we are completing Unit 2 questions. Let's solve Unit 3 questions. What is the output of following code? Let's see the code. A float type array is initialized here. 13.24, 1.5, 4.5, 5.4, 3.5. So this is A index 0, A index 1, A index 2, A index 3 and A index 4. Two float pointers are declared. J is equal to A. A will be starting from address of the first element. J is equal to A is actually address of A of 0. So J is here. K is equal to A plus 4. A plus 4 means 1, 2, 3, 4. So K is denoting the last element of A. So J denotes the first element of A and K denotes the last element of A. J is equal to J into 2. K is equal to K divided by 2. If J is an integer or a float or something, this into will be valid. If K is some other data type, it will be valid. But here they have declared them to be pointers. Pointer arithmetic is for plus or minus for binary operations. So if J is equal to J plus 2, it means it has to move two addresses. If K is equal to K minus 2, it has to move two addresses back. If J is going to be here, then if I say J minus 2, then it will come two addresses back. So the operations that will be allowed will be plus and minus. So into and division will be a part of other arithmetic. So it will not be a part of pointer arithmetic. So these two lines will throw error. Then you are printing and this will also work. There will be no issue. But unless and until you remove these two lines, you will always get an error. So if this is equal to J plus 2 and K is equal to K minus 2, K minus 2 will come back and both J and K will refer to the third element, that is A of 2. So when you run this code in a C compiler, it will give an error, invalid operands to binary operator. So float and float can be multiplied, int and int can be multiplied, but this is a pointer and this is an integer. So 2 is an integer and J is a pointer, so it has invalid operand. Illegal use of pointer in main function. Option 4 will be the right answer. Next question, what is X in the following program? Let's see the program. So first we will take this part. Array F PTR of 3. So pointer of array is declared and here you have the function symbol and then we have placed a pointer again here and we have an array again. So if you are very focused enough, from the name ARRFPTR you can derive three things. ARR stands for array, F stands for function and PTR stands for pointer. With these three words we can declare X is an array of three function pointers. Since function is placed here, this means three function pointers and it's an array of three function pointer because here you have the dimension of the array. Option number 3 will be the right answer. So if I say it is star x with some int or something, then it's a pointer. X is an array of 3 pointer, then there should be no reference in between but only the dimension should be mentioned. Error in X declaration, there is no error, it is fine. Next question. What is the output of the following code? So here a struct is defined. So there are 3 fields totally. This is actually a string of characters. This is integer and this must be some pointer that will be referring some other address location. We are declaring an array. In that we are giving input to this struct. The first record will be Nagpur. I will have 1 and pointer P will have A plus 1. Then Raipur, I will have the value of 2, pointer will have the value of A plus 2. Then we have Kanpur, I will have the value of 3 and pointer will have the value of A. So whenever we say pointer is equal to A, we always say it refers to the 0th address. So I'll just place the index here. It is A of 0, A of 1 and A of 2. Nagpur goes to character, 1 goes to int and A plus 1 goes to pointer P. This is how I have written this part. Struct S1 pointer is equal to A. Whenever we assign an array to a pointer, it will always refer the 0th index. So pointer is referring to A of 0, which means it is referring Nagpur record. Now we are printing 3 strings. So first string is for A of 0 dot Z. Second string is for pointer Z. Third string is for A of 2 pointer Z. A of 0 dot Z. What is A of 0 Z field? Nagpur. So Nagpur is printed here. Now what is PTR pointer? This PTR is again A of 0. So when I mention a pointer, I use this operator to denote the field. So pointer denoting the field Z is again A of 0. So this is again printing Nagpur. And next A of 2. A of 2 is this record. And in that P field, that is the pointer field. What does this pointer field say? It says it as A of 2 dot P points to A of 0. So it says A means A of 0, the first record or the 0th index record. In this case also we have A of 0 dot Z. So the field Z is again Nagpur here. So we are printing Nagpur again. So 3 Nagpur together. Option number 2 will be the right answer. So I'll just tell you what is there in the other 2 pointers. So if you take A of 0 dot P, it has A plus 1. A plus 1 means from 0 I have to move 1 position. So this will be moving to A of 1. A of 1 I have to refer dot Z. A of 1 Z field will have Raipur. When I say A of 2 dot P pointing Z, then it will be Nagpur. When I say A of 0 dot P to Z, it will be Raipur. Okay, let's see what is A of 1 dot P. So it has the value A plus 2. 0 plus 2 will be 2. Dot Z is equal to Kanpur. So this is A of 1 dot P Z field. Whenever I say A, it is referencing the 0th index. When I say A plus 1, it is index 1. When I say A plus 2, it is index 2. Next question, what will be the output of the following code? So they have given 3 integers. A is equal to 10 and B is equal to 10. So what is this 0x and 0? So 0x is a notation for hexadecimal digit and 0 is a notation for octal. Now A is equal to hexadecimal value. So how do you convert this to decimal? So hex to decimal will have in powers of 16 power 0, then 16 power 1, etc. It goes like this. So 1 into 16 power 1 plus 0 into 16 power 0. 1 into 16 power 1 is 16 plus 0, which is equal to 16. A will hold the value of 16. Now B has in octal format, octal to decimal, we will use 8 power. So 1 into 8 power 1 plus 0 into 8 power 0. 1 into 8 is 8 plus 0 into 1 is 0, which is equal to 8. So B is having the value of 8. Now C is equal to A plus B, which is equal to 16 plus 8, which is equal to 24. Printf C, 24 will be printed. The output will be option 2, 24. Though it may seem to be like small o, it is actually 0x, 10 and 0, 10. Option number 2, 24 will be the right answer. Next question. How will you free the memory allocated by the following program? So they have defined rows and columns and they have used malloc for allocating memory. What does malloc do? It is used for dynamic memory allocation. The format will be as it is given. So a pointer will be there. Then you have to use this malloc function along with the size. This is for memory allocation. Here the question is how to free it. So they have given three other functions, namely dalloc, memfree. Malloc will not be there for deallocating obviously, and the next is free of pointer. Memfree is not a part of this language, so let's take it away. What is dalloc? Dalloc is an objective C selector. When an object is no longer owned by any part of application. In other words, we can say when reference count on object drops to 0, the runtime will be calling dalloc. This line makes sure that we shouldn't call dalloc. It will be automatically called when there are no reference counts to the object. It has no work here. The only option left for us will be option number 4. Free of pointer will be the right answer for freeing up the memory allocated. Now let's have a statement about this. This deallocates or frees up memory space allocated by functions like malloc and calloc. It takes only one argument. The argument will be the pointer pointing to the memory location that has to be deallocated. So this will be the only argument and it has no return value. Since there is no return value, we will term it as void. The next question, the next set of 5 questions will be from computer graphics. Sutherland-Hodgman method is used on. Sutherland-Hodgman method is used for polygon clipping. Let's have only option 3 and option 4 and remove 1 and 2. So it's a polygon clipping algorithm. So if you take this polygon like this. So clipping means whatever part you want, that alone will be taken. The rest will be clipped from the viewpoint. 2 kinds of polygons are involved here. One will be the convex polygon and another will be the concave polygon. Convex polygons are correctly clipped by Sutherland-Hodgman method. Option number 3, convex polygons will be the right answer. For concave polygons, we have an algorithm called Wheeler-Atherton. So if you take Sutherland-Hodgman algorithm, when they applied it for concave polygons, it did not do it perfectly. It is a perfect fit only for convex polygons, so they don't use it on concave. Instead, they use Wheeler-Atherton for concave. We will also rule out option number 4. Next question. The clipping process in computer graphics is used for. So previously we saw polygon clipping. I just drew some random structure and I said this will be visible from the viewing part. So this part of removing other sides of the shape will be clipping. Now we will just see which matches the option. Adding graphics, it doesn't add anything. It doesn't copy anything. It doesn't zoom anything. It actually removes objects and lines. So option number 4 will be the right answer. The clipping process is used for removing objects and lines. Let me give you the complete statement. The clipping process is used for removing objects, lines or line segments that are outside the viewing plane. Why do we consider this viewing plane as a constraint to remove is because viewing window has a limited display area. So that becomes the viewing plane. Anything that is outside the viewing plane has to be removed. So that process is what we call it as clipping. Next question. Consider the rectangle with vertices 0, 0, 0, 2, 3, 0 and 3, 2. Just plot it in graph 0, 0, 0, 2. Then we have 3, 0, 3, 2. There is a scaling of 2 towards x-axis and 3 towards y-axis. The new coordinates of the rectangle are, we have seen about scaling transformation denoted by sx and sy. So what is actually scaling transformation is, when we have a coordinate called x, y, when it is scaled, the scaled size will be x dash, y dash, where x dash is equal to x into sx. The scaling factor here, and y dash is equal to y into sy. For now we can take x to be the coordinates that is already given in the question, x comma y. This is sx and this is sy. So the scaling factor is how much it has to be scaled. This is x and this is y. So 0 comma 0. This is the new coordinates x dash comma y dash. 0 into 2 comma 0 into 3. This has to be multiplied by 2 and this has to be multiplied by 3, which is equal to 0 comma 0. So the same place it is. 0 comma 2. 0 into 2 comma 2 into 3. This will give 0 comma 6. Then we have 3 comma 0. 3 into 2 and 0 into 3. This will again give 6 comma 0. Next we have 3 comma 2. 3 into 2 and 2 into 3. This will be 6 comma 6. So the coordinates will be 0 comma 0, 0 comma 6, 6 comma 0, 6 comma 6. Here x-axis has been scaled up to 2. Sx is equal to 2. And this has been scaled up to 3. This is not there. This option is not there. The last one is also not there. So here it is 0 comma 0. It is present. 6 comma 0 is present. 0 comma 6 is present and 6 comma 6 is present. Option number 3 will be the right answer. Next question. Which of the following transforms in 2 dimension is used to resize a 2-dimensional object? Translation is actually for moving certain points. X can move for certain distance, y can move for a certain distance. So it's about moving. Rotation is for rotating a part of angle. So your angle may be changed. Scaling is enlarging or diminishing the image. So previously we saw a rectangle which was in this size was turned to this size. This enlarging or diminishing will be called as resizing the object. Shearing means to change the shape and size of the object along x-axis and y-axis. If it is a rectangle, it may change to a parallelogram. So this is shearing. But when a rectangle is just enlarged as a big rectangle, or when a square is just diminished to a small square, then it is resizing. The transformation that is used to resize a 2D object will be option number 3, scaling. Next question, match list 1 with list 2. We will first go with Bezier curves. In Bezier curves content in computer graphics book, you have a line. Bezier curves are found in painting or drawing packages. Then in CAD systems. CAD is computer aided design. Painting, drawing, CAD is for A. A is mapping to 4. Option 2 and option 4 are ruled out. Next we will go with B-splines. We have usually seen this topic under Bezier curves, but B-splines here are meant for beta splines. Beta splines are generalization of B-splines. Here in beta splines we have two terms named bias and tension. So bias is denoted by B and tension is denoted by C. Usually they say B is greater than 0 for bias. So they have also given B-spline matrix is where B is equal to 1 and C is equal to 0. B-splines will go to option 3, bias and tension. A4 and B3. So option 1 is also ruled out. Option number 3 will be the right answer. Next we have sweep representation. Sweep representations will be for constructing 3-dimensional objects that have translation and rotational symmetry. So this line will be more than enough to explain sweep representation. So C will be mapping to 1. It is used to construct 3D objects. Next is natural objects. The only left out option will be fractal geometry. So we are mapping D to fractal geometry. So what is fractal geometry? It is the geometric shapes that have fractional dimension. They contain detailed structure at arbitrarily small scales having a fractal dimension. There is a statement called fractal geometry is the geometry of natural objects. This way we are connecting natural objects to fractal geometry. With this we are completing unit 3 questions. Let's discuss Unit 4 solutions. Let R with attributes A, B, C, D be a relational schema with the following function dependencies. They have given 4 functional dependencies. The decomposition of R into A, B, B, C, B, D. So if you take A, B, C, D all together to be a single table in the context of relational database, just imagine R is decomposed into 3 other tables. The first table will have the attributes A and B, the second table will have the attributes B and C, while the third table will have the attributes B and D. So this is how they have decomposed the relational schema. A set of options have been given and it is based on two concepts. One is lossless join and the other one will be dependency preserving. Let's first discuss what is a lossless join. If there is a relation R and it is decomposed into two other relations, namely R1 and R2. Let's take this for an example. The decomposition of R into relations R1 and R2 such that if we perform natural join of R1 and R2, it will return the original relation R. So this is called as lossless join. So let's take R1 to be A, B, R2 to be B, C, and R3 to be B, D. So let's perform a join here. So when I join R1 and R2, I will get A, B, C attributes. So when I join A, B, C relation with R3, I will get A, B, C, D. So all the attributes are covered here. It means this will be a lossless join because even if we decompose the relation R into 3 other relations, when we perform a natural join of all these 3 relations, we ultimately end up getting the original relational schema. So this has a lossless join and whichever option say it does not give a lossless join will be removed now. Now we have to check whether this decomposition is dependency preserving or it is not preserving. What is dependency preserving? When we decompose a relation into smaller relations, we preserve the functional dependencies between the attributes. Let's take the first relation A, B. So is there a functional dependency from A to B? Yes, we have. So this relation is fine. Then we'll take the second relation B, C. So do we have a functional dependency? Yes, it is existing. So we have this FD. Let's take relation 3. It is B, D. Taking these two into consideration, from B I will be able to determine C and from C I will be able to determine D. So in this way, all the functional dependencies are preserved even when the relation R is decomposed into R1, R2 and R3. So it is also dependency preserving. In this aspect, we are ruling out option number 2. Option number 1, the decomposition of R into these 3 relations gives a lossless join and it is dependency preserving. We mark option 1 to be the right answer. Next question. A B tree used as an index for a large database table has 4 levels including the root node. If a new key is inserted in this index, then maximum number of nodes that could be newly created in the processes. Considering all nodes are completely full, this means every node has n minus 1 key. So if a new key is inserted, then two things will happen. At every level, there will be a new node created. Level 1, level 2, level 3 and level 4. And the second point will be in the root level. Root node will also be broken into 2 parts. So for 4 levels, we will have 4 nodes. And at the worst case, if the root node is breaking into 2 parts, we will get additionally 1 node. So totally, we can have 5 new nodes at the maximum. The maximum number of nodes that could be newly created in this process will be option 1, 5. Next question, consider the following statements. It is all about 3NF, BCNF and 4NF. When will we say a table is in 3NF? when the transitive dependencies are eliminated, the relation will be in third normal form. When will we say it is in BCNF? A relation must be in 3NF, and for a functional dependency X determines Y, X must be a candidate key or a super key. You can also take the other way. If Y is going to be the prime attribute, then X cannot be non-prime. So this will be the case of BCNF. A database design is in BCNF if each member of the set of relation schemas that constitutes the design is in BCNF. This is actually true. Next statement, a BCNF schema can have transitive dependency. Transitive dependencies are eliminated in 3NF. If it is already a 3NF, then a BCNF schema cannot have transitive dependency. So in this case, we mark B to be false. Once we conclude that B is false, whatever option involves B will be ruled out. From this we can mark option 4, A, C and D only will be the right answer. Now we will just check C. It is always possible to obtain a 3NF design without sacrificing a lossless join. There is a statement supporting this. They say it is possible to get third normal form without sacrificing lossless join or dependency preservation. This is also true. If we don't eliminate all transitive dependencies, we may need to use null values to represent some of meaningful relationship. So this is an additional point added to the C statement. Next statement, there are multi-value dependencies in 4NF. In second normal form, we eliminate partial dependencies. In third normal form, we eliminate transitive dependencies. In that case, multi-value dependency can be removed by 4NF. But when you get on to the explanation or definition of 4NF, there is a point stating no non-trivial multi-value dependencies other than candidate key. No important multi-value dependencies other than candidate key should be there. So in other terms, we can say this builds on BCNF. So from 3NF we go for BCNF, and from BCNF we go for 4NF. This builds on BCNF but must not contain more than one multi-value dependency. Actually, multi-value dependency will create redundancy. That's why they are trying to remove it in 4NF. So that one multi-value dependency might be because of this candidate key. So here there are multi-value dependencies in 4NF. From this statement we can say D is true. Next question. Given below are two statements. Which of the following concurrency control protocol ensures both conflict serializability and freedom from deadlock? Serializability is a term where every event will be occurring in some sequence or in some order. They have given two statements. First statement is about two-phase locking and second one is about timestamp ordering. Two-phase locking is based on locks and deadlocks may occur. When the term says it may occur, freedom from deadlock does not apply for two-phase locking. Though deadlocks may occur, it ensures conflict serializability. In this case, two-phase locking will not be the protocol that ensures both the things. So statement 1 will be false. Next is timestamp ordering. This will be based on timestamps and this ensures both conflict serializability and freedom from deadlock. So statement 1 is incorrect but statement 2 is correct. Option number 4 will be the right answer. So they have given in two-phase locking that deadlocks may occur. So what will be the step that will be taken is cascading rollbacks. Next question. Which one of the following is not a part of ACID properties of a database transaction? A stands for atomicity, C stands for consistency, I stands for isolation and D stands for durability. So option number 4, deadlock freedom will be the right answer. It is not a part of ACID property. Next question, let R, A, B, C, D, F be a relational schema with following functional dependencies. So they have given few dependencies and they are asking which of the following is a key for R. Every option will be denoting a key. We have to find which is the correct key for R. So we will evaluate every key and find whether we are able to get all the attributes of relational schema. So let's start with CD. So from CD, I will be able to take the attributes C, D. Are there any functional dependencies starting from C? Yes, we have C derives F. So from C derives F, I will be able to find F. There are no dependencies with D. So only 3 attributes can be found. Let's take the second option, EC. Basically, we can find E, then C. From C, I can find F. It holds this. From E, I can find A. So E determines A. With EC together, I can find D. So D is also added here. And then A determines B. Using this, I can find even B. So all the 6 attributes are covered. Let's check the other 2 options, though we know option 2 will be right. AE. From AE, I can find AE. From A determines B, I can find B. E will determine A again. So I don't have C here. So it will stop with these 3 attributes. Next we have AC. So basically we can find AC. From A I can find B. From C I can find F. So the only key that will be able to give all the attributes will be EC. Option number 2 will be the right answer. Next question, which of the following scenario may lead to an irrecoverable error in a database system? A transaction writes a data item after it is read by an uncommitted transaction. Here we have an error. First we'll see what are the statements that produces error, then we'll find which is irrecoverable error. A transaction reads a data item after it is read by an uncommitted transaction. So this operation is also read by uncommitted transaction and this is also read. This will not give you any issue, so no issues will be there. A transaction reads a data item after it is written by a committed transaction. Once it is a committed transaction, when another transaction reads a data item, it will produce no issue. So this also ends up with no issue. A transaction reads a data item after it is written by an uncommitted transaction. Whenever uncommitted happens and a write is involved, it will end up with error. So in this case we have uncommitted, but both the operations are read. But here we have one write and one uncommitted. Here we have one write and one uncommitted. So you can always have this clue. When there is a write operation involved and when there is an uncommitted transaction together in a scenario, this will end up with error. When it is a read operation or when it is committed transaction, we will have no issue. So let's take the first case. If the transaction write commits, then read might get phantom tuple or unrepeatable error. Here there is no irrecoverable error. So obviously we know option 4 will be the right answer. This fourth statement will be giving irrecoverable error. Let's take 2 transactions T1, T2. Let's have a set of time here. We'll start with the data item A and read operation. There is a write operation to A and there is a read operation for A and read operation for B, write operation for B, then a read operation for B here. In the 7th time slot, it is getting commit here and the commit for T1 will be in 8th time slot. Now this T2 is actually reading updated value of A before the commit operation of T1. See here we have a read operation of A that will do no issue. I am writing the value of A. It means updating the value of A. So once I update A, the commit statement is occurring only in the 8th time slot. But before the commit happens, the uncommitted write, so written by an uncommitted transaction is this. The uncommitted write is read. R of A is given here. So T2 is reading the updated value of A from write of A. So here this situation is depicted in the diagram. The transaction T2 is reading a data item A after it is written by an uncommitted transaction T1. This is something like a dirty read. So this becomes the irrecoverable error. Next question. Given the basic ER diagram and relational model, which of the following is incorrect? ER diagram can have entities, relationship, and the attributes in the ER diagram will be represented using many symbols. In this case, ER attributes can be multi-valued. ER attributes can be composite. Multi-valued in the sense you can take if there are 2 or 3 phone numbers. So phone 1, phone 2, everything will be stored together. And if you take composite attributes, the example will be like address. So if you take address, it will be split into 3 other fields like door number, street name, and city. So this is composite, and multi-valued is a single field having multiple values. Coming to the case of relational model, the attributes will have atomic value. This atomic value can be exactly one value belonging to a particular data type, or it can be of null value. Anyway, this null is also a single value given to that attribute. So let's check the statements now. An attribute of an entity can have more than one value. So entity is in the context of ER diagram. So it can have more than one value. It means it is multi-valued. So this is possible and one is marked as true. An attribute of an entity can be composite. Again, it belongs to ER context. This is also true as we saw here in the row of a relational table. So this is about relational model. An attribute can have more than one value. No, this is actually false because it can have only one value. It means it has atomic value. In a row of relational table, an attribute can have exactly one value or a null value. This is what we saw here. So this statement is also true. The only statement that is incorrect will be option number 3. So usually we know we convert ER diagrams to relational tables. So what will we do when ER has multi-valued attribute and when ER has composite attribute? What will happen in relational database? So when it is a multi-valued attribute, we just create a separate table to store those fields. Say for example, I can have the ID, I can store the phone numbers separately, phone 1, phone 2 as single attributes. Regarding composite, the parent will be lost and siblings are present. It means address will be removed. Instead, the number, the street name and the city will be included in the table. Here it is the parent and here these are the siblings. So in this case, this will be lost and this will be existing in relational table. Here multi-valued, it will have a new table along with the values. Even composite will have a new table, but their address field will not be existing. Instead, it will be with the sibling attributes as fields. Next question. The total cost of retrieving records in sorted order using an unclustered B plus tree. So they have given P denotes the average number of records per data page and N is equal to the number of data pages. So the total number of data records will be P into N or N into P. They have given F to be the ratio of the size of a data entry to the size of a data record. Here we have another count. Number of leaf pages in this tree will be F into N. So total cost will have the formula of F plus P into N. This will be the total cost of retrieving records in sorted order using unclustered B plus tree. So they say that F is usually less than or equal to 0.1 and p is greater than 10. Because f is going to be very small, this will not have any effect here. So p into n will be giving a good approximation. Option number 2 will be the right answer. Next question, matching list 1 with list 2. Actually, RAID belongs to unit 5 operating system topic, but RAID is also discussed in DBMS books and in some computer architecture books too. So for the purpose of keeping 10 questions in one unit, I have just kept RAID here in unit 4. Let's see what are the RAID levels. We have up to 6 levels: 0, 1, 2, 3, 4, 5, 6. 0th level, non-redundant stripping will happen. The first one will be with mirrored disks. Then the second one will have memory style error correcting codes. Third level will have bit interleaved parity. Fourth level will have block interleaved parity. Fifth level will have block interleaved distributed parity. And the sixth level will have P plus Q redundancy. The diagrams will be present in the books. You can have them for reference. Now we'll just map the options. Level 2, A will be mapping to memory style error correcting code. So it goes to error correcting parity. A will be mapping to 3. Option 1 and option 4 can be removed. Next, RAID level 4. It is block interleaved parity. B is mapping to 4. Option 3 is also ruled out. Option number 2 will be the right answer. Let's check C and D. RAID level 5 is about block interleaved distributed parity. So C is mapping to 2. And RAID level 3, it is bit interleaved parity. D is mapping to 1. With this, we are completing Unit 4 questions. Let's discuss Unit 5 solutions. At a particular time of computation, the value of a counting semaphore is 7. Then 20 P operations and X number of V operations were completed on this semaphore. If the final value of semaphore is 5, what will be the value of X? P operation is for wait and V operation is for signal. So whenever there is a P operation or a wait operation, you have to decrement the value. Whenever we have a signal operation or a V operation, we have to increment the value. Usually they will ask you the final value of semaphore, but this time they are asking you the value of V operations count. So the initial value of the semaphore will be 7. The number of P operation will be 20. The number of V operation will be denoted by X, and the final value of the semaphore is 5. Initial plus V minus P is equal to the final value of the semaphore. So instead of initial, I am substituting it by 7. Instead of V, I am having it as X. Instead of P, I am using 20, and instead of the final value, I use 5. So 7 minus 20 will be minus 13 is equal to 5. X is equal to 5 plus 13. X is equal to 18. So there are 18 V operations. Option number 3, 18 will be the right answer. Next question. In a multi-user operating system, 20 requests are made to use a particular resource per hour on an average. Per hour, 20 requests. The probability that no request is made in 45 minutes. An event can occur 0 time or 1 time or 2 times in an interval. Average number of events is equal to lambda. So this lambda is also called as event rate or rate parameter. The probability of observing k events in an interval. So here we can place 1 time, 2 times or k number of times, denoted by P of k events is given by the formula lambda power k e power minus lambda divided by k factorial. K denotes the number of events. So here event is equal to the request made. Since no request is made, we are mentioning k is equal to 0 for this problem. For 45 minutes, k is equal to 0. So we have to find lambda. Lambda is equal to 45 into, for 1 hour we have 20 requests, so 20 divided by 60. 45 is also in terms of minutes, and 1 hour is also converted to minutes. Dividing by 60, we are converting it to minutes. Now if we cancel this 0, 2 into 3 times, 3 into 15 times, lambda is equal to 15. So the average number of events will be 15. Now we will find the probability. No requests for 45 minutes. P of 0 is equal to lambda power k e power minus lambda divided by k factorial. Let us substitute the value. 15 power 0 e power minus 15 divided by 0 factorial. 0 factorial is equal to 1, and 15 power 0 is also equal to 1. So the final answer will be e power minus 15. Option number 1 will be the right answer. Next question. Consider the following table of arrival time and burst time for 3 processes P0, P1 and P2. The preemptive shortest job first scheduling algorithm is used. So whichever job is having least or short burst time will be executed. They have used the term preemptive. It means you can take two processes. One process is coming with 3 burst time and the second process is coming with 2 burst time. At arrival time 1, this will be executing. Once I get the second process with a lesser burst time, I can preempt to this process. It means I can shift to another process. So preempting is I can give the CPU to another process. Scheduling is carried out only at arrival or completion of a process. What is the average waiting time for the 3 processes? So let's use a Gantt chart here. So we'll start with 0. At 0 milliseconds, P0 is arriving with a burst time of 7. I am executing it for 1 millisecond. At time 1 millisecond, P0 will have 7 minus 1, 6 burst time, and we have another process coming in P1. P1 has a burst time of 3. Now we have to choose the one with the shortest job. So here P1 gets selected and we are preempting it to the next process. This time it will be P1. At time 2, we will have P0 is equal to 6. P1 is equal to 3 minus 1, which is equal to 2. We have another process coming in, P2 with the burst time 7. Now if we choose the shortest job, it is P1 again. So we can complete P1. Again and again it is going to be reduced only. So at time 4 milliseconds, P1 will complete its job. You can even put for 3. When it is 3, P0 will remain 6, P1 will have 1 and P2 will have 7. Again we are choosing this. At 4 we will have P0 is equal to 6, P1 is equal to 0. It means the job is over and P2 is equal to 7. Now select the shortest job again. We are going with P0. Again when you keep decrementing by 1, P0 will be executing continuously. So I will place P0 in this Gantt chart, and for 6 burst time it will be executing. So 4 plus 6 around 10 it will complete. After P0 is over at 10, we will have only P2 process with 7 burst time. So P2 will execute from 10 to 17. So around 17 all the 3 processes will be completed. Let's calculate the waiting time for the processes first, then we'll take the average. You can do this in 2 ways. First way, you can find the completion time. P0 is completing in 10, P1 is completing in 4 seconds and P2 takes 17. So this will be the completion time of all the 3 processes. From this we have to find turnaround time. This is nothing but completion time minus arrival time. 10 minus 0 is 10. 4 minus 1 is 3. 17 minus 2 is 15. From this we will calculate waiting time. This will be the difference between turnaround time and burst time. So 10 minus 7 is 3. 3 minus 3 is 0. And 58 minus 7 will be 8. In short, without getting detail into this chart, we can also find. Just find when is P0 starting. It came at 0. and it started immediately. Again, in between it has waited for 3 milliseconds. So the wait time of P0 will be 3. Again it started its execution at 4 and it continued till 10. So there is no wait time and the process got over. For P1, there is no wait time at all because it came at 1 and it got executed completely. So in this case, P1 will have 0 waiting time. If you take P2, at 10th millisecond, it started its execution and it completed at 17. But when did it arrive? It arrived at 2 milliseconds. So 10 minus 2 will be 8. 8 milliseconds will be the waiting time. You can either calculate like this or you can use this turnaround time and then calculate wait time. It is all up to you. Whichever way you are comfortable, you can carry out. Now we will find the average waiting time. Totally there are 3 number of processes. 3 plus 0 plus 8, which is equal to 11 divided by 3, and this will give approximately 3.67 milliseconds. Option number 2 will be the right answer. Next question. Consider a disk system with cylinders. The request to access the cylinders occurs in the following sequence. Assuming that the head is currently at cylinder 50, what is the time taken to satisfy all requests if it takes 1 millisecond to move from one cylinder to adjacent one, and shortest seek time first policy is used. So from the disk head I have to take the shortest seek time. So let's place the sequence in ascending order. Head is at 50. It can either move to 34 or to 73. We have to calculate the shortest seek time. So 73 minus 50 will give 23 and 50 minus 34 will give 16. So we are going with 34. 50 to 34. From 34 I have to travel back to 73 or 20, which is short. So from 34 only 14 movements are needed to go to 20. So we are choosing 34 to 20. So here the movement number is 16. Here it is 14. So hereafter we need not touch 73 because 20, 19, 15 will have shorter time. 20 to 19 it is 1. 19 to 15 it is 4. 15 to 10 it is 5. 10 to 7 it is 3. 7 to 6 it is 1. 6 to 4 it is 2, 4 to 2 is 2. Once it reaches this end, then it will travel back to the next end. So from 2 it will move to 73. So in between we have 71. This will be a total of 119 milliseconds. This is the total head movement. Now we have to calculate the time taken to satisfy all requests. To move from one cylinder to another cylinder, the time taken will be 1 millisecond. Time taken to satisfy all requests, or in short we can say the total seek time, equal to 119 into 1, which is equal to 119 milliseconds. So option 1 will be the right answer. Consider the following statements. Statement 1. LRU, least recently used page replacement algorithm, suffers from the Belady's anomaly. Let's first understand what is Belady's anomaly. It's a phenomenon where increasing the number of page frames results in an increase in number of page faults. The page replacement algorithms that are experiencing this anomaly will be FIFO, first in first out, second chance algorithm, random page replacement algorithm. So in this list we don't have LRU, so S1 is false. S2, shortest remaining time first, SRTF, may cause starvation. When the process doesn't get CPU, it is called starvation. SRTF will cause starvation for long CPU burst process because they never get the CPU. Why they don't get CPU is because shorter processes keep coming. So the algorithm says it is shortest remaining time first. So whenever a shorter process comes, those processes will be getting the CPU again and again. And because of this, longer burst time process will never get the CPU. When such a situation is existing, we can say it suffers from starvation. S2 statement is true. This may cause will denote the longer process will be suffering. S3, stack is shared by all threads in a process. See, regarding thread, we have a statement. Every thread has its own stack, register, and program counter. Only the address space is shared by all threads for a single process. So here the statement stack is shared by all threads is false. So S2 is true while S1 and S3 are false. Option number 2 will be the right answer. Given below are two statements. One is labeled as assertion and the other is labeled as reason. Assertion says input-output protection is ensured by a hardware trap. Trap is nothing but a software interrupt. Reason. Input-output interrupt caused by the condition like I/O completion and device malfunction occurring within the I/O devices. Normal user programs are prevented from handling I/O directly by I/O instructions. It means the user programs don't give I/O instructions directly. Then who takes care of it? System calls take care of it. In other term, we can say I/O protection is ensured by OS routines, operating system calls. A is wrong because it is not ensured by hardware trap. There are 2 points in this. The first point is for CPUs having explicit I/O instruction. I/O protection is ensured by having I/O instructions privileged. But in a CPU with memory mapped input output, there is no explicit I/O instruction. In that case, the I/O protection is ensured by the operating system routines. So this statement is the exact cause for marking A to be false. So in general, they used to say all the interrupts are handled via system calls. That's why in the starting I said normal user programs are prevented from handling I/O directly by I/O instructions. So let's look at R. I/O interrupt caused by the condition like I/O completion and device malfunction occurring within the I/O devices. This statement is actually true. These two conditions, whether it's I/O completion or device malfunction that occurs within the input-output devices, they cause interrupt. Option number 4. A is false but R is true will be the right answer. Next question. Given below are two statements. One is labeled as assertion and the other is labeled as reason. A process involves a library function to create a thread. This is true. The threads make system calls to convey their resource and input-output requirement to the kernel. This is also true. Now we have to find whether R is the right explanation of A or not. Actually, processes start with a single main thread. The main thread can create new threads. A process can have multiple threads. Threads take less time to terminate as compared to process. One process has so many threads. The job will be split to multiple threads. So automatically thread will take less time to complete or to terminate compared to the whole process. Here they are saying the process is involving a library function to create a thread. This is about creating a thread from process using some system call. Here they are saying the threads make system calls to convey their resource and their requirement to the kernel. This is about the thread and this is about the process to create a thread. This is actually not an explanation of A. So in this case we are marking option number 2. Both A and R are true but R is not the correct explanation of A. Next question. Again we are given two statements, one with assertion and other with reason. A virtual memory system uses first in first out FIFO page replacement policy and allocates a fixed number of frames to a process. Increasing the number of page frames allocated to a process sometimes increases the page fault rate. This is nothing but Beledi's anomaly. We saw FIFO is also experiencing this. So assertion is obviously true. The reason, some programs do not exhibit locality of reference. What is locality of reference? It is a phenomenon in which program tends to access same set of memory locations for a particular time period. So this property is generally shown by loops and subroutine calls. Some programs do not exhibit locality of reference is also true, but there is no connection between FIFO replacement and locality of reference. So we can mark both A and R are true, but R is not the correct explanation of A. There is no relation between A and R in concept of page replacement. So they are talking about virtual memory system and FIFO replacement policy. Assertion is related to the statement given above it, but the reason is not supporting the assertion. Next question. Given below are two statements. Which of the following statements are correct with respect to virtual memory? First statement. Address translation is performed for every logical address used during the execution of a program. Translation from logical to physical address is performed by operating system's memory management unit. This part is true. Second statement. A program can execute only when all of its components are loaded in the memory. We have to find whether this is true or not with respect to virtual memory. Before that, we'll first see about dynamic loading. Dynamic loading is the entire program and all data of a process must be in the physical memory for the process to execute. This is with regard to physical memory. Here we have to answer with respect to virtual memory. Virtual memory is a technique that allows execution of processes that are not completely in memory. Programs can be larger than the physical memory. In fact, with virtual memory, a system can load larger or multiple programs running at the same time. A program can execute only when all of its components are loaded in the memory is true for physical memory, but with this point we can say statement 2 is false. That's why they have given in the starting as with respect to virtual memory. So statement 1 is correct, but statement 2 is incorrect. Option number 3 will be the right answer. Next question, match list 1 with list 2. So first we'll start with deadlock. Each process must be waiting for some resource, and that resource will be held by another process, which in turn is waiting for the first process to release the resource. So if you take process 1, it holds resource 1. This resource 1 is needed by another process P2, but P2 is holding resource 2, which in turn is waiting for the first process to release resource. It is a circular wait. Deadlock will be mapping to 4. So we will rule out option 1 and option 4. Now let's check working set. Working set is the memory being accessed frequently by an application. There is one term that will also refer to the same set of memory. It is principle of locality. Elements in close proximity are referred. Similar to the explanation we saw for locality of reference. Working set will go with principle of locality. So C is mapping to 3. Now we have critical region and wait or signal. So first we will find what is horse monitor. Horse monitor is similar to semaphore. It has the ability to lock or wait for a lock to view data. The work will be similar to semaphore. We will map wait or signal to horse monitor. B1. So again we can rule out option number 3. Option 2 will be the right answer. So critical region will be obviously mapping to mutual exclusion. Mutual exclusion implies that only one process can be inside the critical session at any time. If any other process requires the critical section, they must wait until it is free. Since we have mentioned about critical section, we are mapping critical region to mutual exclusion. With this, we are completing Unit 5 questions. Let's discuss Unit 6 solutions. An observational technique that can be used to understand operational process and help to derive requirement for software to support operational process is known as. What is requirement specification? It is actually the collection of all requirements that are necessary for design, verification, and even maintenance of product. So in short, we can mention collection of requirements. This does not talk about observational technique. Next is structural specification. In short, we can say it is about architectural design. That is how a software system is to be developed in order to achieve the goals that are specified in the requirements. Next is ethnography. I think you could have come across this term, ethnographic research. It is actually done by way of observation. So this is the observational technique. Now we can map it. Ethnography is an observational technique that can be used to understand operational process and help to derive requirement for software to support operational process. So ethnography will be the right answer because this is the only observation technique out of these four. Then what is natural language specification? From the word natural language, we can understand it is the normal plain text that we use. So it's a way of writing requirements in normal plain text. This is natural language specification. Next question. Which of the following is used to determine the cost performance index? In short, we can call it as CPI. So what is cost performance index? It's a method to calculate cost efficiency and financial effectiveness of specific formula. So CPI is given by the formula earned value divided by actual cost. There are three conditions here. If the CPI value is less than 1, it means the project is over budget. They might have allocated some amount as the budget and the project is going beyond that. When the value is equal to 1, it means project is on budget. And when the value is greater than 1, it means project under budget. So here they have given budgeted cost of work performed and budgeted completion, then actual cost of work performed. So keeping this term actual cost in mind, we are removing option 1 and option 2. Earned value is written as budgeted cost of work performed. Now we look at the operator here. It is divided by. So here it is subtraction. We will rule out even fourth option. Option number 3. CPI is given by the formula budgeted cost of work performed divided by actual cost of work performed. So this is budgeted cost divided by actual cost. Next question. Which is intended to show that a system both conforms to its specifications and meets the expectations of the system customer. What is software specification? It is the specification of requirements. SRS document usually lists that. The software requirement specification document usually carries that. What is software design? It is about transforming the requirements to some other form. So we will do coding and other kinds of implementation in order to transform the requirements to some product or to some form. What is software evaluation? This is done in order to detect dysfunctional and unused software. Usually some parts of the software might not be used and this process will detect that. When all these three don't go with the statement above, we can obviously know option 4 software validation will be the right answer. So what is software validation? This will check if the software has met the client expectation as well as whether it has met all the specifications mentioned in the requirements. So software validation will be the right answer. Next question. The following table shows the time between failures for a software. Time between failures, TBF. The error number is given. So there are totally 5 number of errors and the time since last failure in hours has been given. The reliability of the system for 1 hour operation assuming an exponential model is, we have reliability of time is equal to e power minus t divided by mtbf. So everything is in the power only. T is the time actually. Here this is T. For 1 hour operation, T is equal to 1. What is MTBF? Mean time between failure. The time between failures have been given. TBF. Mean time means you have to sum up all the time between failures and then divide it by number of failures. So here the number of errors. So mean time between failure will be 6 plus 4 plus 8 plus 5 plus 6. I am taking all the time and summing it up, divided by the number of errors or the number of failures will be totally 5. This is just the count. This is first one, this is second one, this is the count. So there are totally 5. 1, 2, 3, 4 and 5. 6 plus 4, 10, 10 plus 8, 18, plus 5, 23, plus 6, it is 29 divided by 5. Now, reliability for 1 hour operation is equal to e power minus 1 divided by 29 by 5. When I have something as fraction in the denominator, I place the fractions denominator in the numerator. So, this will be e power minus 5 by 29. Option 3 will be the right answer. So the time between failures have been given. You are just calculating the average of it and applying it in the reliability formula. Next question. Consider a popular sports news site. At a given moment, 20,000 concurrent users submit a request, a transaction T, once every 2 minutes on average. Each transaction requires the web app to download a new article that on average it has 3K bytes in length. What is the throughput? This comes under web app testing. It's to uncover errors in the web app. Uncover errors in the web app's content, function, usability, performance, security, etc. So I am just giving in short as web app. There is something called load testing. Load testing is about how the app is going to respond to various loading conditions. Now they have given number of concurrent users to be 20,000. So this will be denoted by capital N. N is equal to 20,000. Then we have the number of transactions per unit time. That will be denoted by T. So T is equal to once every 2 minutes. So this can be written as 1 by 2. Out of 2 minutes I get 1. Here the throughput is given in second. So here it is 1 by 2 minutes. So what we will do is we will change into seconds. So 1 by 2 into 60 seconds. We are not bringing seconds to the numerator. We are just keeping it in denominator. This is equal to T. Next we have the data load processed per transaction. The data load will be represented by capital D. Here they say the transaction requires the web app to download a new article. This will be the data and the size of the article will be 3K bytes in length. 3K bytes. They are asking for the throughput. The formula for the throughput P will be capital N into T into D. 20,000 into 1 divided by 2 into 60 seconds into data is 3K bytes. So here I can cancel 2 and 2. We have 3 into 10,000, 30,000 divided by 60. Now K bytes will stay and this seconds will go up per second. Now cancelling this I have 500. So the value here will be 500 kilobytes per second. Now the answer is given in megabits. So we have to convert it. 500 KB per second is equal to 500 into, this K can be written as 2 power 10. So 1K is equal to 2 power 10. 1 mega is equal to 2 power 20. Instead of this bytes, 1 byte is equal to 8 bits. I am just converting into 8 bits per second. Now this is 500. How can I express 500 in terms of 2 power? So 2 power 10 is 1024. Then 2 power 9 will be 512. So this is approximately equivalent to 500. So I am expressing this in the form of 2 power 9 into 2 power 10 for the kilo. Then into 8 can be expressed as 2 power 3 here. So it is 2 power 3 bits per second. I have converted the byte to bit. That's why I have mentioned here bits per second. From this I am taking 2 power 9, 2 power 10 into 2 into 2 power 2. 2 power 3 can be written as 2 power 1 into 2 power 2. Now combining these two, I can say it is 2 power 10 into 2 power 10 into 2 power 2. So altogether we will have 22, which means 2 power 20 into 2 power 2. 2 power 2 is equal to 4. So I have 4. 2 power 20 is m, and here it is bits per second. So it is 4 megabits per second. This answer is matching in option number 2. Option number 2, 4 megabits per second will be the right answer. Actually the calculation is over here, but you need to convert into the form in which the option is given. That's why we are doing this set of calculation. Next question. Consider the following statements about the software product line system. In advanced software engineering, there is a concept called product line system or the software product line system. Only in advanced software engineering books you can find this topic. There are two statements given. At the interaction level, components provide an operator display interface and an interface with the communication system used. Statement 2. At the I/O management level, components handle operator authentication, report generator and query manager. Now we will just know what is software product line. This is a set of software intensive system that share common managed set of features satisfying a particular market's need. Actually, it is developed from a common set of core assets. These assets can be components, framework, library, a tool, development or execution platform. The assets can be any of these. So they have given a list of components. The statement 1. The components provide an operator display interface and it is responsible for interaction at next level. It is up to this and then we continue. And the second point, a point of connection with many communication methods are employed. The second point is the second half of the first statement, interface with the communication system used. So this is at the interaction level. Statement 1 is obviously true. And next, components handle operator authentication located at level 2 I/O management. So at the I/O management level, they handle operator authentication is also present. I could fetch only these many points. If you have any idea about advanced software engineering books, you can just go through for some more details. So this statement is also true. Keeping these points under consideration, we are marking option 1. Both statement 1 and statement 2 are correct to be the right answer. Next question. Given below are two statements. One is labeled as assertion and the other is labeled as reason. Assertion states validity checks real need of system users. Validity is used to check whether the system is performing the functions proposed by the users. Assertion is actually true. This checks the real need of system users. The reason. Completeness checks system user defined requirements. This is also true. What kind of requirements are these? Requirements cover all aspects of the system. It can be functionality, performance, reliability, security and usability. All the aspects of system are covered in this requirements. So completeness will check system user defined requirements. In the light of above statements, choose the correct answer from the options given below. We know that both A and R are true, so option 3 and option 4 are removed. Do you think completeness is going to be a reason for validity? It is obviously not. R is not the explanation of A. Validity is checking about the needs of the user. It's about the function that the system has to do. Completeness is about covering the overall aspects of system. Actually, functionality will be one of the aspects that is taken care of validity. The rest, like performance, reliability, security, and usability, should also be covered in this requirements list. So, taking this point, we say that option 1 is also wrong. Option 2, both A and R are true, but R is not the correct explanation of A because only one aspect functionality is checked by validity. Completeness is checking all aspects of the system. Next question, given below are two statements. Statement 1, subsystem models show logical grouping of object into coherent subsystem. Statement 2, state machine models show how objects change their states in response to events. We have a topic called UML design models. It is divided into two types broadly. One is structural model. The other one is dynamic models. Structural model is actually static in nature. It specifies about the object classes and their relationships. As the name goes, dynamic models are dynamic in nature and it shows or it depicts the interaction between the system objects. Under dynamic models, we have sequence models. The sequence of object interactions represented using the UML sequence diagram or collaboration diagram. The second model will be state machine models. The state machine models show how objects change their states in response to events. This will be the right definition. And it is represented using state diagrams. These diagrams are high level models of a system or the object's runtime behavior. So state machine model statement is true. Now let's check the first statement. Subsystem models are represented using a form of class diagram with each subsystem shown as package with enclosed objects. And this subsystem models will be static structural models. Grouping of objects into coherent subsystem is what they mention as package with enclosed objects. So statement 1 is also true. Option number 1, statement 1 and statement 2 are correct, will be the right answer. Next question, consider the following statements and they are asking us to choose the correct answer from the options given below. Dynamic metrics are collected by measurements made of a program in execution. This is true. Why are they collected? To measure what? This is to assess efficiency and reliability. Static metrics are collected by measurements made of representations of the system. This is also true. This is used to assess complexity, understandability and maintainability. A and B together we have only two options. So we will remove these two. The assessment of software quality is an objective process. Software quality involves partial or complete code review, architecture review, testing, and it has to assess a software product's compliance with development standards. Software quality assessment is done to find defect in the software product. So assessment is not an objective process. We are marking C to be false. The next statement, an important part of quality assurance in the selection of standards that should apply to the software development process. Usually, when we assess a software product, it has to be in compliance with the development standards. So, the important part will be in the selection of those standards only. This statement is also true. Option 1 is also ruled out. Option number 4, A, B and D will be the right answer. Next question, match list 1 with list 2. 4 types of testing are given. What is scenario testing? Scenario testing is the documentation of a use case. The meaning is perfectly mapping in fourth option. So we will rule out second one and fourth one. Next is regression testing. It is a testing that runs after every change that we make to ensure that the change introduces no unintended breaks. Because of changing something in the program, it should not develop new bugs or new errors in the system. For that purpose, we go with regression testing. So here the third option, no new bugs after changes in program, is perfectly right for regression testing. B is mapping to 3. Next we will check for component testing. Component testing is also known as program testing or module testing, and this is done after unit testing. The objects can be tested independently as a component without integrating with other components. So option number 1, to verify the input-output behavior of test object. C will be mapping to 1. Option 3 has C mapping to 1. So we will rule out even option 1. Option number 3 will be the right answer. Next is beta testing. Beta testing is also called as user acceptance testing, and real users perform this testing. So beta testing will be mapping to user acceptance methodology. D is mapping to 2. So option 3 will be the right answer. With this we are completing unit 6 questions. Let's discuss unit 7 solutions. A three-dimensional array in C++ is declared as int a of A, B and C. Consider that array elements are stored in row major order and indexing begins from 0. Here the address of an item at the location A with 3 indices R, S, T computed in terms of word length W of an integer is. In general, array will be stored in continuous memory location. So if you take a 2D array, that is only with rows and columns, you can refer this to 0, 0. Since it is row major order, table will be in this format. This is row and this is column. So row 0, 1, 2 and column 0, 1, 2. So 0, 0, 0, 1, 0, 2, it goes on. Similarly 1, 0, 1, 1, it goes on. This is the way it will be accessed if it is row major order. Here there are 3 dimensions to an array. The last 2 dimensions will be the row and the column respectively. What is this A, the first index? It will be that particular block. Say for example, if you take this to be the 2D array. So this is row 0 and row 1. This is column 1 and column 2. Here there is another dimension. This will say to which block does these rows and columns belong. We can term it as block, or we can say it is a set of 2D array. So this block will have a set of 2D array. This block might have a set of 2D array. Let's interpret this representation first. A with index A, B and C. Index A denotes the number of 2D arrays. It will be ranging from 0 to A minus 1. So usually this will be called as block, that blocks row and that blocks column. B will be the number of rows. It will be ranging from 0 to B minus 1, and C will be the number of columns, 0 to C minus 1. The base address, that is the first address, will always be with index 0. So 0 will be there in every index. It will be block 0, row 0 and column 0. Now they are asking there is an item in the location A of R, S, T. It means it is rth block, sth row and tth column. Computed in terms of word length W. So once you find that location, you have to multiply it with the word length of integer W. Let's interpret A of R, S and T. What does this R say? The item is located at rth block. So this rth block will have a 2D array consisting of B number of rows and C number of columns. So I have to skip R minus 1 2D arrays which will include B number of rows and C number of columns. So I said the range will be from 0 to A minus 1 for block in this case. So if I have to access the rth block, it means I have to skip r minus 1 blocks. If I am in the fifth block, it means I have to skip 4 blocks. So if I say it's the rth block, it means A of r 0 0. It means I am in the starting of the rth block. This is rth block, 0th row and 0th column. So now if I have to skip these many blocks, then I have to include both the rows and the columns count. So it will be r times of b rows and c column. How many positions should I move? I have to move R into B into C. When I say I have to move R blocks, it is including those rows and columns inside that block. So I can say A of R is reached in this position. Okay. Now I have to reach A of R Sth row. Now the block is selected. So there is nothing we can do with the block. Now it is the usual 2D format. If I want to go to the fifth row, I have to skip 4 rows. Say for example, if I include this row, it will also include the columns. When I say it is A of R then S of 0, it means I am in my rth block, Sth row and 0th column. Here R block is fine, we have already found. Now we have to calculate for Sth row. So for Sth row, it means I have to multiply S into the number of columns, which is C. So S into C will be taking me to the corresponding row. Now we will have R, S and T. Here we have reached rth block, we have reached Sth row. Now we have to find the exact column. If I want to find it in 9th column, I have to skip 8 elements. So I can directly reach T. If you take R into B into C, then S into C, then T. Now I have to add all these things. R into B into C plus S into C plus T. This will actually be the correct location of the item. So where do you find this? It is in option number 2. It is perfectly matching. So they have taken rows into column into block, then column into row, then the column number. And the base address is given by A of 0, 0, 0. Since the index is beginning from 0, ampersand of A will tell you the exact address. Option number 2 will be the right answer. Now you can find there is something called W into. Since it is computed in terms of word length W, we are multiplying the whole set by W. This will actually give the address of the item in the location rth block, Sth row and Tth column. This is the way of interpreting step by step. Now there is a formula for this. Formula to access an element at A of I, J and K. This will be ith block, jth row and kth column. First B, we will add the base address. So let me expand here. Base address plus, if there is any storage size for the element, we can mention it. It is represented by W. Here they have used integer W into, in general, for this table we have m number of rows, n number of columns, and they have given some lower bound of m rows and n columns. I am not including those details inside. I am just giving you whatever is needed for this answer. Okay. So now m into n into the block I plus n into the column count into the row j plus k. For this problem, capital M is equal to B and capital N is equal to C. I is equal to R, J is equal to S and K is equal to T. Now if you substitute it here, you will get it. Instead of base address, they have given ampersand of 0th index, and instead of small w, here it is capital W. Next question, suppose A circular queue of capacity n minus 1 elements is implemented with an array of n elements. Assume that the insertion and deletion operations are carried out using rear and front as array index variable respectively. Initially, rear is equal to front is equal to 0. The conditions to detect queue empty and queue full. What is a circular queue? It's a queue whose last position will be connected back to the first. It will be in the form of circle. You will have the element storage. Whatever you insert, it will be inserted in the rear position. Whatever you delete, it will be deleted in the front position. Just imagine a normal queue. Whoever enters first will be going out first. If you take stack, whichever comes last, that will be taken out first. So it is last in, first out. But here queue is first in, first out. Whichever enters the queue first will be coming out first. Okay. Insertion process is also called NQ and deletion process is called DQ. This insertion will take place like after inserting in the last position, the next element is inserted at first position. So let's start with queue empty condition. When can I say the queue is empty? When both front and rear end up in the same place, or when they have the same index, I can say the queue is empty. They have given initially both have 0, but queue empty condition will be when rear index is equal to front index. So wherever you find empty rear is equal to front, we will keep that option. The rest of the option can be ruled out. Now let's check what is queue full condition. Let me give you a small example. Take the index of rear to be 4 and front to be 0. There are totally 5 elements to be inserted. So I am inserting it from 0, 1, 2, 3, 4. So since I have not deleted anything, front is having the same 0th value. So when I insert all the 5 elements, this will hold the first element and this will hold the last element, which means it is holding the 5th element. If I want to delete, I will proceed with the first element. This example scenario is queue full scenario. How can I check this? I can check it with this condition, rear plus 1, that is 4 plus 1 mod n. 4 plus 1 mod 5 will be equal to 0. So this will be equal to front. There are 5 elements in the circular queue. The first element will be in front and the index will be 0. And now the last element inserted will be in the rear position and the index will be 4. For better clarity, I am changing it to element 1, element 2, element 3, element 4 and element 5. First I will insert in this position. Then when I insert my second element, the previous element will move here and the second will be inserted here. When I insert the third element, the first element will move here, second one here and the third one will sit in the rear position, rear index correctly. Similarly, when I insert fourth element, the first element will come to this position, that is index number 1. So this is index 1, index 0, index 2, index 3 and index 4. When I insert the fifth element, the first element will be pushed to index 0. So from the back, it will be pushing it little by little to the front. So in that way, we make a computation with rear plus 1 mod n is equal to front. This will say whether the queue is full or not. So I get a value of 0 in this example, which is the value of front. It is rear plus 1 and here it is front plus 1. So obviously we will drop option 4. Option 1 will be the right answer. Next question. Consider a hash table of size 7 with starting index 0 and a hash function 6x plus 3 mod 4. Since they have placed the options in horizontal manner, let me also depict the hash table in horizontal manner. It is starting with the index 0. So we have started the slot numbering from 0 and ended up at 6. There are totally 7 slots available. The hash function will be 6x plus 3 mod 4. Assuming the hash table is initially empty. Which of the following is the content of the table when the sequence 1, 3, 8, 10, 5 is inserted into the table using closed hashing. What is closed hashing? Closed hashing is also called open addressing. Here if collisions occur, they will be stored in another slot. There is other type of addressing in which if collisions occur, they will be stored separately. But in open addressing or closed hashing, when two or more contents of the table go to the same slot, if there is already an element present in the slot, it will be stored in another slot. Here underscore denotes an empty location in the table. Now let's compute this. 6 into 1 plus 3, this is 9 mod 4. 4 twos are 8, so remainder 1. So 1 will be placed in the first slot. Then we will compute for 3. 6 into 3 plus 3, 18 plus 3, it is 21 mod 4. So 4 5s are 20. Again it is coming to the first slot. So since first slot is already occupied, we are just moving to the next slot. 3 is occupying the second slot. This is the use of closed hashing. Next we have 8. 6 into 8 plus 3. 48 plus 3 will be 51 mod 4. So 4 12s are 48. Then the remainder will be 3. So the third slot will have 8. Then 10. 6 into 10 plus 3 will give 63 mod 4. 15 into 4 will give 60. Again there is a remainder of 3. So we will move to the next slot and store 10 in fourth slot. Then we have 5. 6 into 5 plus 3. This will give 33 mod 4. 4 8s are 32. Remainder will be 1. And here 1 is occupied, 2 is occupied, 3 is occupied, 4 is occupied. And so we are placing 5 in the fifth slot. Wherever the slot is free, use underscore and then write the elements in the horizontal way. So this is perfectly matching in option number 4. So option number 4 will be the right answer. Next question, given below are two statements. One is labeled as assertion and the other is labeled as reason. The AVL trees are more balanced as compared to red-black trees, but they may cause more rotations during insertion and deletion. This is a true statement. The heights of AVL trees as well as red-black trees are generally same, but AVL trees require frequent rotations to maintain their balance. So because of that, they say they are more balanced. Okay, the statement is true. The reason, a red-black tree with n nodes has height that is greater than 2 log 2 n plus 1 and the AVL tree with n nodes has height less than log 5 of root 5 into n plus 2 minus 2. This 5 is called the golden ratio. So red-black tree will have a height less than or equal to 2 log n plus 1 and AVL tree height will be less than log with the base 5 root 5 n plus 2 minus 2. So AVL's comparison is less than, that is right. But here they have given red-black tree has height that is greater than, which is wrong. Actually it is less than or equal to, since this part is wrong. It is less than or equal to, we mark R to be false. So we are not getting into option 1 and option 2. We are ending up with option 3. A is true but R is false will be the right answer. Next question, given below are two statements. Let f of n and g of n be asymptotically positive functions. The following conjectures in the sense guesses, something of that sort, are given. So statement 1 says f of 1 is greater than 1, which means f of n is a positive constant. By the definition of big O, f of n will be less than or equal to c into g of n for some positive constant c. From this we can conclude g of n is greater than or equal to 1 by c f of n. And this statement is actually a definition of transpose symmetry. The statement will be like f of n equals to big O of g of n if and only if g of n is equal to omega of f of n. So statement 1 is true. Statement 2, f of n is equal to big O of g of n. Now they are applying log to this, and they have given log of g of n is greater than or 1 for all sufficient large n. F of n is less than or equal to c into g of n. Now I am applying log here. Log of f of n is less than or equal to log of c into g of n, which is less than or equal to log of c. I am applying log. Since I am splitting it, I have a plus here, log of g of n. From here, I can say it's less than or equal to log of c and log of g of n plus log of g of n. This is because they have given log of g of n is greater than or equal to 1. That's why we are bringing this. We will bring log of g of n outside. So log of c plus 1 into log of g of n, which means log of f of n is less than or equal to, this is in the form of constant into g of n, log of g of n. Now here this is equivalent to this part and this is equivalent to this part. So here, since log of g of n is greater than or equal to 1, instead of 1 I am placing it. This is like log of c into 1. This is again like in the form of c into g of n. So instead of c, here it is log c, and here instead of g of n it is log of g of n. So I am just placing it back like big O. So from big O I took this part. So from this part I am again making it as big O. Okay, I could just simply say the statement 2 is also true. Option number 1, both statement 1 and statement 2 are correct, will be the right answer. Next question, given below are two statements. One is labeled as assertion and the other is reason. Assertion is, it is possible to create doubly linked list using only one pointer with every node. There is a supporting statement. It is possible to implement a doubly linked list using a single pointer per node by storing XOR of addresses of the previous and next nodes. So the single statement is split here. They say there is a possibility to create doubly linked list using only one pointer. So this is true, and how they create is by storing the XOR of addresses of previous as well as next node. So if you take this to be the doubly linked list, usually if this is the node, this will be the link to the previous node and this will be the link to the next node. This is also true. This becomes the reason of A. This method of storing the XOR of the address is actually memory efficient because the list uses bitwise XOR operation to save space for one address. Instead of actual memory address, every node will store the XOR of address of previous and next node. So from this we can conclude that both A and R are true and R is the correct explanation of A. Option 1 will be the right answer. Next question. Consider the following statements about heap sort algorithm. Max heapify procedure, which runs in O of log n time, is the key to maintaining the max heap property. This will maintain the max heap property as well as this runs in O of log n time. This is true. The build max heap procedure, which runs in O of log n time, produces max heap from an unordered input array. Actually, the content about the procedure is right, but the running time is wrong here. So we will mark it as false. Build max heap procedure runs in linear time. The max heap insert, which runs in O of log n time, implements the insertion operation. This is true. A and C included in any answer? Yes, it is included in two options. I am removing the rest of the option here. But when I say B is wrong, I automatically say 4 is also wrong. So option number 2, A, C only will be right. Then what is wrong with statement D? The heap increase key procedure runs in O of n log n time to set the key of new node to its correct value. Again, the explanation of the procedure is right, but the time is wrong. There are 4 procedures: max, heap, insert, heap extract max, then heap increase key, then heap maximum. All these 4 procedures take same amount of time. I mean, they run in big O of log n time. It means whatever time C takes, the same time D will take. So it is not n log n, it is big O of log n. With these procedures, we can implement a priority queue. The heap sort procedure runs in big O of n log n time and it sorts an array in place. Next question. They have given 4 statements and they are asking which are right from the options. If some NP complete problem P is in P, then P is equal to NP. The depiction will be, this is NP and this is P. This part will be NP hard and here this part will be NP complete. This is in the case where P is not equal to NP. Now when P is equal to NP, the scenario will be, this will be NP hard, but here P is equal to NP and it is approximately NP complete. When we take this depiction into consideration, if some NP complete problem P is in P, then P is equal to NP is what this diagram says. So A is true. We can remove option 2. Next, TSP, traveling salesman problem is in NP. This is actually true. It is in NP. To check if the total cost of edges of the tour is minimum, it can be completed in polynomial time. That's why we are marking it to be true. The next statement is satisfiability problem is in NP. SAT is also in NP because any assignment of Boolean values to Boolean variables that is claimed to satisfy given expression can be verified in polynomial time by a deterministic Turing machine. So this is also true. A, B and C are true. They have given only 3 statement possibilities. So option number 1 will be the right answer. 3 and 4 are also ruled out. Hamilton circuit problem is not NP complete. This is false because Hamilton circuit problem is NP complete. Though we have seen that C is right, let me give you one more point. Satisfiability problem as well as circuit satisfiability problem. Both are NP complete. Next question, match list 1 with list 2. The running time of straightforward recursive method to compute the nth Fibonacci number Fn. When we say something is in the form of recursion, we go with the power of some 2 or we take exponential time. We can mark 5 power n. Option A will be mapping to 4. Option 1 and option 3 are ruled out. Next, the running time to compute Fn using memoization. So what is memoization? It's an optimization technique to speed up by storing results of expensive function calls and return cached result when the same inputs occur again. So when we use memoization, the running time will be reduced. From this we can say B will be mapping to 3. So A4 and B3, we will even rule out 4. So option number 2 will be the right answer. Next statement, the running time to compute Fibonacci number Fn using only integer addition and multiplication. For that it will take big O of log n. So C will be mapping to 2. The running time to determine an optimal bitonic tour. What is bytonic tour? This minimizes the total amount of horizontal motion with ties broken by Euclidean distance. Then what is optimal bytonic tour? The bytonic tour with minimum total length. So when you go for tour, you will already have lots of movements. So it will end up with a complex time. We find big O of n square is high here. So we are assigning option 1 to D. The next question. Match list 1 with list 2. First one is parallel FFT, fast Fourier transform. What is parallel FFT? From the name you can understand this will segment the FFT into groups of identical parallel operations. So this will have parallel operations that can be performed concurrently and independently. This will take log n time, and so we are mapping A to 3. 2 and 4 are ruled out. Next we have iterative FFT. So there is something called recursive FFT where recursion takes place. This uses the classic divide and conquer method. But iterative FFT is little bit different from recursive because this saves the recursion stack space, and this will take n log n time. So B is mapping to 4. Option 1 is also ruled out. Option number 3 will be the right answer. Next is evaluation of polynomial at n points by Horner method. This will take n square time. C is mapping to 1. And product of two polynomials that are represented in point value form. This will take n time. The reason why it takes less time is because of the point value form. Now let us see what is the point value representation of polynomial. So let's take two polynomials A and B, and the product will be C. Let me show you the representation first. This will be in the form of x0, y0a, then x1, y1a until the end. I am not ending up, I am just showing you the representation alone. The polynomial B will be of the form x0, y0b, x1, y1b. The product A into B will be in the form x0 will stay, and the product of y0a and y0b will be taken. x1 will stay, y1a and y1b will be taken here. So this is the way the product will be computed. Then what is point value representation? It's a set of n point values pairs. The representation of x0, y0, x1, y1 is actually in the form of point values. This product computation will take only theta of n time. We are aware of the product of polynomials using coefficient form. When it is done using coefficient form, this will take n square time. Now you can understand how much it is efficient. So this is about point value representation. Now a little bit of detail about Horner method. We can say as Horner's rule polynomial. So what is Horner's rule polynomial? Let's take a polynomial a0 plus a1x plus a2x square plus up to an x power n. This will be represented as a0 plus, I am bringing this x outside, and I have a1 plus, then I am bringing another x outside, a2. When you multiply these two, you will have a1 into x. When you multiply x with these two, you will get a2 x square plus x into a3. It goes on till x into a power n minus 1 plus x into an. This evaluates n degree polynomial with n multiplications and n additions. So additions are this and multiplications are this part. It's an efficient algorithm to compute value of polynomial. With this we are completing Unit 7 questions. Let's discuss Unit 8 solutions. Consider the following finite automata F1 that accepts a language L. They have given the transition diagram. Let F2 be a finite automata which is obtained by reversal of F1. Then which of the following is correct? In the reversal of an automata, all the transitions will be preserved. Let's take the reversal automata. The final state becomes the initial state here, and the initial state becomes the final state. And the states in between will be in the reversal order. Here there is only one state, so we are just placing it between the initial and the final state. We have to check whether all the transitions can be applied in the reversal automata too. So there is a transition from C to S. There is a transition from S to E. There is a transition from C to E. So this one, this one, this one, they are preserved. Then we have E to S, S to C and E to C. So E to S, S to C and E to C. Now we have preserved all these transitions. So now they are asking whether the language generated by F1 and language generated by F2 will be equal or will not be equal or will be the subset of the another. So we have to find this. Since all the transitions are preserved in this automata, we can say that the language generated by F1 will be equal to the language generated by F2. So option number 2 will be the right answer. When I have the same set of transitions in F1 and F2, obviously the language generated by both the automata will be same. Next question, which of the following statement is correct? Let's start with the first statement. Ackermann's function is primitive recursive. First, let's understand what is primitive recursive function. It's a function computed by a program whose loops are all for loops. It means the upper bound of the number of iterations can be determined before entering the loop. Just we'll have the structure. Before entering the body of the loop, we will know how many iterations it has to go. So during every increment or during every iteration, we'll be knowing what is the upper bound. But if you take the case of while loop or do while loop, this condition will be checked here and the increment of the condition will happen here. So only in for loop this will be possible. So this is called as primitive recursive function. Let me give you the Ackermann's function and then tell you whether it is primitive recursive or not. This is represented by a of m comma n. There are three conditions here. If m is equal to 0, it is n plus 1. If m is greater than 0 and n is equal to 0, it will return m minus 1 comma 1. So it's a recursive function. There is no doubt with this format, but we have to check whether it is primitive recursive. If m is greater than 0 and n is greater than 0, the call will be m minus 1 a of m comma n minus 1. When you want to represent factorial problem or Fibonacci problem in terms of recursion, we use this format. In primitive, they say that all the loops will be for loops. But here in Ackermann function, to implement this, we will use while loops and not for loops. Taking this to be the reason, we say that Ackermann's function is not primitive recursive. So 1 is not correct. The second statement is the language a power n, b power k, c power n plus k, n greater than or equal to 0, k greater than or equal to 0 is regular. So to check whether a language is regular or not, we have to go with the pumping lemma. I'm not going to explain pumping lemma here. Instead, I will just list the rules of pumping lemma. So let us take a string w. It will be in the form of x, y, z. And we have to check three rules here. The first one is the length of y should be greater than 0. It should not be equal to 0. The second condition will be when you take the length of x and y, it should be less than or equal to m. So m is a constant that will be assigning a value. The third one is x, y power I, z should also be in the language for all I greater than or equal to 0. So even when the y part is missing. For y power 0, the string should be in the language. Let's take m is equal to 3 for the purpose of pumping lemma. Now let's find the strings available in the language first. So n is equal to 0, k is equal to 0. This will give a power 0, b power 0 and c power 0. So L will have empty string. Then for n is equal to 0 and k is equal to 1. B and c. So BC, k is equal to 0 and n is equal to 1. We'll have AC. Just substitute in the language and find it out. Let's take n is equal to 1 and k is equal to 1. A will have a power 1, b will have b power 1, c will have c power 2. So A, B, C, C. When you have n is equal to 3 and k is equal to 3, we'll have triple A, triple B and 6 number of C's. The count of number of A's and the count of number of B's. When you add them together, it will be the count of number of C's. By pumping lemma, we can express this language in the form of a power m, b power m and c power 2 into m. So m plus m will give you 2m. We have already taken the value of m to be 3. Now let's take the longest string here. The condition will state that we have to select the string that will be greater than or equal to m. W is equal to triple A, triple B, triple C 2 times. Okay, now I have to split it as x, y and z. How should I split this x, y, z? When you take the count of x and y together, it should be less than or equal to m. So here m's value will be 3. So I can take 3 characters together to be x and y. Now I can split this xy as a for x and a for y, or it can be a for x and double a for y. For the third rule, when you eliminate one y stating y power 0, so they say I is greater than or equal to 0. So it can be x into y power 0 into z. So let's take this case. It is double A and y power 0 means this A will be missing. Then you will have triple B and 6 C's together. Is this string in the language? No, it is not. Similarly, you can take this to be the case. For x, y power 0 is z. I can have x here and I can eliminate this y in the name of y power 0. Then I will have triple P and 6 number of C's. Is this in the language? No, it is not. When this x into y power I into z for all I greater than or equal to 0 is not in L, it means the language is not regular. So this is not a regular language. And moreover, when you try to represent this in the form of regular expression, you can express A as A star, B as B star, and for C you cannot say the number of counts. So here the condition of the expression will be like when you add the number of A's and number of B's, you should get the number of C's. But in regular expression, you cannot express that. You can also think this way to say that this is not a regular language. The conclusion will be option number 2 is also wrong. Now let's check option number 3. They have given a language and they have told this is not context free language. So this is a power n, b power j and n is equal to j square. By pumping lemma, let's take the string w to be in the form of u, v, x, y, z. So let's take the language to be in the form of a power m square into b power m. So we have to express it using the same variable here. Here also we will take the value of m to be 3. Now let's see the conditions that has to be checked. First condition will be the length of Vy should be greater than or equal to 1. The length of Vxy, the center part, excluding u and z, it has to be less than or equal to m. And the third one will be u v power I, x y power I, z should also be in the language for all I greater than or equal to 0. Here let's take sample strings of the language. So for n is equal to 3, j is equal to 9. So you will have 9 A's, 1, 2, 3, 4, 5, 6, 7, 8, 9, and you will have 3 B's. This will be the string that we are going to work out. So let me place 9 A's and 3 B's. Now I have to choose such that Vxy will be less than or equal to 3. Some 3 A's will be chosen. In that case, if I take V power I, Y power I as 0. So if I is equal to 0, I have to eliminate 2 A's here. When I eliminate 2 A's here, there will be only 7 A's remaining in the string. Is this string in the language? No, it is not. With this case, we can conclude that this language is not context free, and this statement is the correct statement. So option 3 will be the right answer. So obviously now we will know option 4 is also wrong, but we will just see what is wrong with that. For every context sensitive language L, not including lambda, there exists some linear bounded automata, that is LBA M, such that they have given L not equal to L of M, but this is actually L is equal to L of M. This will be the right statement. They have also said if a language L is accepted by linear bounded automata M, then there exists a context sensitive grammar that generates L. So this statement is also supporting L is equal to L of M. Since they have given it is not equal to, we are marking this also to be wrong statement. So from this we can say the language A power n B power j, where n is equal to j square, is not context free language. This is the only right statement out of these 4 options. Next question. The maximum yield length of the following CNF CFG. So CNF is Chomsky normal form and CFG is context free grammar. They have given some productions here. Yield is a terminal string represented as W. The value of W will be less than or equal to 2 power n minus 1. N is the height of the longest path in tree. Now let's take S. When I do this derivation, S has A, B non-terminals. Then A has C, D as non-terminals. I can have E here because B is producing E, and C will have A and D will have B here. This is the yield. This yield has 3 terminals, but based on the height we have to tell the maximum yield length. Height 0, height 1, height 2, height 3. So n will be equal to 3. Let me substitute n here, 3 minus 1. So this will be 2 power 2 and this will give 4. The maximum yield length of the following CFG will be option number 3, 4. So the tree is nothing but the past tree here. Next question. Consider the following language. W belongs to A, B, C closure. Number of A's in the string plus number of B's in the string will give number of C's in the string. So let's first understand what is linear. A language generated by a linear grammar is linear language. In linear grammar, each production has at most one non-terminal. At most in the sense it will be less than or equal to 1. So every production doesn't have the non-terminal, or it will have only one non-terminal, not more than that. So non-terminals are usually represented by capital letters and terminals are represented by small letters. And there is also another point. Any linear grammar is context free, but not all context free are linear, because when you have more than one non-terminal it doesn't fall under linear grammar. Now we have to check whether the particular language is context free and then we'll check for linearity. So here they have given the number of A's and number of B's. When they are added together it should give number of C's. So let's for example take 2 number of A's and 2 number of B's and end up with 4 number of C's. So you have 2 A's, 2 B's. When you add 2 plus 2, it will give you 4. So this is number of A and this is number of B, and 4 will be the number of C. This is what is given here. How can I convert this into a context-free grammar? First, we have to understand one thing. Whenever there is a, there should be a C. Whenever there is a B, there should be a C. Only then this condition can be satisfied. So for every A accompanied by C, I can generate a rule AC. For every B accompanied by C, I can have BC. Now when I write it in the form of grammar, I can just write S derives ASC BSC. Since it is given in the form of closure, it doesn't mean that I have to go with this order. I can also go in any order. So for that purpose, for ASC, I can also write it to be CSA. I mean, C can also have one A and C can also have one B. So CSB. This doesn't give you any order due to the closure symbol. At the same time, since star is used, it means there can be no string also. So in that case, I can also include epsilon here to indicate that there is no production. Actually, for producing ASC or CSA, there are two ways to derive AC or CA. Similarly, when I have BSC and CSB, this is to derive BC and CB. So there are two ways of deriving it. So the grammar has epsilon for the smallest string. Similarly, we are introducing SS. For one possibility it will be 1S, and for the other possibility you will have other S. So I can also include SS. I have to rearrange this grammar properly. SS, ASC, CSA, BSC, CSB and epsilon. Both the versions are right, but whenever you write, you should always start with non-terminals together and then end up with null string. That will be good. This is actually context free. Just check whether you are able to derive the strings. So S will give SS, then this will give ASC and this will give BSC. Now I am just giving null value here and this will end up with ACBC. Just count the number A plus B. This is also 1, this is also 1 and there are 2 C's. So this is satisfying the condition given here. We are not worried about the order. We are only worried about the count of C, whether it is equivalent to the sum of A and B. Okay. And this can also have a derivation like SS. This can be ASC, this can be epsilon, and this can be ABSCC. This will end up with epsilon. So the final string will be ABCC. This will also give 1A, 1B and 2C. Different kinds of derivation, but the rule number of A plus number of B is equal to number of C is the main thing here. So from this we can say that the language is context free language. It means not context free and linear will be ruled out. Now we have to check whether it is linear or not. In linear grammar, I have already told the production should have at most one non-terminal. It means it can either have one non-terminal or it need not have any non-terminal. But here if you take, there are two non-terminals SS. So violating this rule, we can say this language is not linear. In this case, we are marking option number 1, context free but not linear, to be the right answer. Option 3 is also ruled out. So to check for linearity, you have to check the number of non-terminals. They have only one non-terminal, they are fine. There are no non-terminals, this is also fine. But here there are two non-terminals, which is against this rule. Next question. The compiler for high-level language that runs on one machine and produces code for the other machine is called. When you see the definition of cross compiler, Cross compiler is capable of creating executable code for a platform other than the one on which the compiler is running. This states that it runs on one machine and produces codes for the other machine. So from this statement we can understand option number 1, cross compiler, will be the right answer. An example of cross compiler will be a compiler running on PC. It will generate code that runs on Android phone. Now what is multipass compiler? So this will process the source code of a program several times. It means it will have several passes. What is optimizing compiler? This will try to minimize or maximize some attributes of an executable computer program. The reason for doing this is it will optimize the compilation process. What is one pass compiler? This will process the input exactly once. That is one pass. So cross compiler will be the right answer for this question. Next question, which of the following parser is most powerful parser? Already we have discussed in one question paper about the order of complexity among the parsers. So let me give you that order. Canonical LR, which is called as CLR, is more powerful than LALR, look ahead, which is greater than SLR, and this is greater than LR of 0. So this will be SLR of 1 and this will be LALR of 1. And what is canonical LR? It is LR of 1. This will be the order. So in this we have to understand what is operator precedence parser. It is a bottom-up parser that interprets on operator grammar. They also say it's a shift reduced parser, and this parser will be a subset of LR1 grammars. In any way, canonical LR is the most powerful parser. Option number 3 will be the right answer. Next question. Which phase of compiler checks the grammar of programming? What does it do in code optimization? This will transform code in a more efficient way without changing the output. What is semantic analysis? This will check if the language constructs are meaningful and also whether the language constructs are consistent with the language definition. What are code generators? They convert intermediate code to machine code. This code will be executed by the target system. What is syntax analysis? If you take the compiler phases, it will start from lexical analysis and then move to syntax analysis. This syntax analysis phase takes a stream of tokens from lexical analysis phase and checks whether they comply with the grammar of the programming language. Which phase of compiler checks the grammar of programming? It is syntax analysis phase. Option 4 will be the right answer. Next question. Given below are two statements. If f and g are two functions and f is equal to O of g and g is equal to O of f, we say that the growth rate of g is smaller than that of f. For the same statement, the actual growth rate of g is greater than that of f, not smaller. We have seen proofs related to this in Unit 7 regarding asymptotically positive functions. We have already seen. So let me give you a small reminder. So if f is equal to big O of g, this means that f is less than or equal to some constant into g of n. F is smaller than g here. In this case, if you take O of g of n, asymptotically grows no faster than g of n. We can say f of n also grows no faster than g of n. When I say f cannot go above g, the growth rate of g will be greater than f. But the statement given here is g will be smaller than f. So this statement is false. The second one, the class of all decision problems decided by a Turing machine in exponential time, that is big O of 2 power k, k being a constant. This part is wrong. What is the right thing? All decision problems are solvable by Turing machine in exponential time, and the time will be big O of 2 power p of n. So what is p of n? It is polynomial function of n. You can also express this like big O of 2 power n power k. Taking this into consideration, we are marking statement 2 also to be false. So option number 2, both statement 1 and statement 2 are incorrect. Next question. They have given 4 statements and they are asking us to choose the correct answer from the options given below. The set of Turing machine codes for Turing machine that accept all inputs that are palindromes, that is possible along with some other inputs, is decidable. The set of codes for TM to accept all inputs that are palindromes is not decidable. So they say it is undecidable problem. A is false. Remove the options that have A. The next statement. The language of codes for Turing machines M that when started with blank tape eventually write a 1 somewhere on the tape is undecidable. This is actually true. All these statements you can find in theory of automata books or articles regarding that. The third one, the language accepted by a Turing machine M is L of M, and this is always recursive. Here I would like to add some details. The language accepted by the Turing machine M is recursively enumerable, denoted by RA. Recursively enumerable will have recursive inside it, and inside recursive we will have CFL, and inside CFL we will have regular. But if you want the language to be accepted by the Turing machine, then it should be recursively enumerable. Then what about recursive? The subset of recursively enumerable language accepted by the Turing machine that always halts are called recursive. When you get a scenario where the Turing machine halts, then it is recursive, because this is going to be a subset of the recursively enumerable part. But when it has to be accepted by TM, then it has to be recursively enumerable. When it accepts, it is recursively enumerable. When it recognizes the language and the Turing machine halts, then it is recursive. So this statement, the language accepted by the Turing machine is always recursive, is false. Next statement, post correspondence problem is undecidable. This is also true. Once you find C to be false, you can take out 3 options from the right answer. So option number 4, B and D only will be the right answer. Next question. This question has no key. Consider the following statements. A context-free language is generated by LR grammar if and only if it is accepted by a deterministic push-down automata called as DPDA and has prefix property. What is prefix property? If a string W is in L, no prefix of W is in L. When you add some prefix to the string W, this new string added with the prefix should not be a part of the language. That is prefix property. Now there are statements like context-free languages are accepted by PDA. Language accepted by DPDA must obey prefix property. This point ensures this part is true. And this statement continues like this language accepted by DPDA with empty stack must obey prefix property. This is actually same as the language generated by the LR of 0 grammar, which is stating this part to be true. To support this part generated by LR of 0 if and only if it is accepted by DPDA, we have one more statement. Every deterministic context-free language DCFL can be parsed by LR of 0 grammar. So we can mark A to be true. Next statement, if M1 is the single tape Turing machine simulating multi-tape Turing machine, then the time taken by M1 to simulate n moves is n power 3. It is not n power 3. The time taken by M1 to simulate n moves is we go off n square. So B will be false. Automatically we can remove three options. But A has to be included in the answer set. None of the four options are having A and excluding B. And here they have given option 3 as C and D only, but we already know A is true. So this is also not there. That's why no key has been declared. Next statement. Push down automata behaves like a Turing machine when it has one auxiliary memory. The supporting statement for C will be a push down automata or PDA if contains more than one stack. Usually PDA will be implemented by a stack. That's why they have given if it contains more than one stack, and this more than one stack can be taken as the auxiliary memory. When it has two stacks, the second stack will be the auxiliary memory. Then it is a Turing machine. So this statement is also true. The next statement, L is equal to A par n, B par n, C par n greater than or equal to 1 is not CFL but context sensitive. Let's take n is equal to 3. Triple A, triple B, triple C. As per the pumping lemma, let's take the string to be U, V, X, Y, Z. So we have to check for this. So if V, X, Y contains only A's, so only from the A part we are choosing V, X, Y. According to the third rule from the pumping lemma of CFL, we have V par I, X, Y par I, where I greater than or equal to 0. So in this case, when I mark I is equal to 0, from the number of A's, I will be removing at least 2 A's. Then A's count will not be equal to B's count and C's count. Once A becomes less than the number of B's and C's, that is not a valid string generated by the language. So the language is not context free is true. So you can also take another way. If Vxy contains only B's, so when I is equal to 0, the B's count will be lesser than the count of A's and C's. So this also is not a part of the language. So not context free is right. But we have to check whether it is context sensitive. Context sensitive language will be generated by the context sensitive grammar. So what is context sensitive grammar? It's an unrestricted grammar in which productions are of the form alpha derives beta, where alpha's length will be less than or equal to the length of beta. And what are alpha and beta? Alpha and beta are strings of terminals and non-terminals. Restricted grammar will be in regular language, but as you go higher, it will become unrestricted. What can you understand from alpha, beta are strings of terminals and non-terminals? It means the left hand side will have a combination of terminals and non-terminals, and the right hand side will also have a combination of terminals and non-terminals. S derives A, S, B, C or A, B, C. Then we have C, B derives B, C. Then we have B, B derives B, B. Two stacks will be needed for this grammar. Just the previous statement we have seen PDA with one more stack, that is when it has one auxiliary memory, it behaves like TM. So we can construct Turing machine for this language. When you have a combination of terminals and non-terminals both in the left hand side and right hand side of the production, then we can call it to be context sensitive grammar. What grammar is this? This is the grammar of the given language. Though we may say we can construct Turing machine for that, but for context sensitive language we have a term called linear bounded automata. And the linear bound automata is nothing but it is a non-deterministic Turing machine. See, usually in Turing machine you will have both the ends open, but in linear bounded automata the ends will be bounded. That's why it is called so, linear bounded. And you cannot have a very lengthy input due to the bound present. So that is the difference between linear bounded automata and Turing machine. This is the context sensitive grammar for the given language A par n, B par n and C par n. So the statement D, the language is not context free but context sensitive, is also true. So the right answers will be A, C and D. All these three statements are true. This will be the right answer for this question. With this we are completing Unit 8 questions. Let's discuss Unit 9 solutions. The first 5 questions of this unit are all repeated questions from the previous year question papers. In the standard Ethernet with transmission rate of 10 Mbps, assume that the length of the medium is 2500 meter. The size of a frame is 512 bytes. The propagation speed of a signal in a cable is normally 2 into 10 power 8 meter per second. The transmission delay and propagation delay are. Transmission delay will be given by packet size divided by the bandwidth. Here packet size is nothing but the frame size and bandwidth is the transmission rate. So packet size is 512 bytes divided by transmission rate is 10 megabits per second. We know that 10 to the power 3 will be 1K and 10 to the power 6 will be 1M. We can write this as 10 into 10 to the power 6, and here 512 by 10 into 10 to the power minus 6, the per seconds here will be going to the numerator as seconds. So 512 divided by 10 will give 51.2. 10 to the power minus 6 is microseconds. So transmission delay will be 51.2 microsecond. It is here. So option number 2 will be the right answer. Now we will calculate propagation delay, and the formula will be distance divided by speed. Distance here is nothing but the length of the medium and speed is given as propagation speed here. So distance is 2500 meter divided by the propagation speed is 2 into 10 to the power 8 meter per second. Meter get cancelled and per second will move to the numerator. So 2500 divided by 2 into 10 to the power 8 can be written as 10 power 2 into 10 power 6 and seconds will move to the numerator. So 2500 divided by 2 into 10 square is 100 and we can move 10 to the power 6 to the top as 10 power minus 6 seconds. I am cancelling 2 zeros here and 225 will be cancelled at 12.5. So 12.5 microseconds will be the propagation delay, and it is right here. The next question, a TCP server application is programmed to listen on port P on host S. A TCP client is connected to the TCP server over the network. Consider that while TCP connection is active, the server is crashed and rebooted. Assume that the client does not use TCP keep alive timer. Which of the following behaviors are possible? The TCP application server on S can listen on P after reboot. If the TCP server is dedicated to one process, it will start listening to the process at the client even after reboot. So statement 1 is marked as true. So consider the server is dedicated only to one process. So in that case, it can listen to the client on that port. But in general, once the current session ends because of a crash and a new connection is established because of reboot, this new connection can take place on the same port. So this statement also supports statement 1. Next statement, if client sends a packet after the server reboot, it will receive the RST segment. Since there is no keep alive timer, after reboot, TCP server may not remember any info regarding the previous connection. In that case, if it receives packet from the client, it may generate the reset segment, which is mentioned here as RST segment. A TCP segment is sent with RST flag when a connection request is received on destination port, but no process is listening at that port. Here the case is the client is sending a packet and it is receiving the RST segment, and they say RST will be sent from the server only. So this case is also true. In light of the above statements, choose the correct answer from the options given below. Option 1, both statement 1 and statement 2 are true. Next question. Consider two hosts P and Q that are connected through a router R. So take this to be P, this is Q, and this is router R. The maximum transfer unit value of the link between P and R is 1500 bytes and between R and Q is 820 bytes. A TCP segment of size 1400 bytes is transferred from P to Q through R with IP identification of value is given. Assume that IP header size is 20 bytes. Further, the packet is allowed to be fragmented, that is, don't fragment flag in the IP header is not set by P. It means the packet can be fragmented. Which of the following statements are true? Let's see how the 1400 bytes are transferred. So the capacity between P and R will be 500. So 1400 will be sent from P to R. At R, we have 1400 now. The maximum transfer unit between R and Q is 820 only. Out of that, the IP header will take 20 bytes. The packet will be fragmented here. So the first fragment will have 800 bytes with 20 IP header, which is equal to 820. Then if you take the second fragment, just deduct 800 from 1400, you will get 600. Along with that, we will add the IP header and this will give 620. This will reach Q from R. Let's check the statements. Two fragments are created at R. It is true. An IP datagram size carrying the second fragment is 620 bytes. So the first one is 820 and second one is 620. Statement A is true. Whichever options excludes A will be excluded. The second statement, if the second fragment is lost, then R resends the fragment with IP identification value of the given value in the question. If the second fragment is lost, what will happen is P will send 1400, the complete segment, to R, and R will fragment it again and send it to Q. While sending identical copy of earlier datagram, a host may optionally retain the same ID field. We are not sure about this value. So in this case, we are marking B to be false. Next statement. If the second fragment is lost, then P requires to resend the entire TCP segment. Yes, in this scenario, we have seen such thing only. So C is true. Next statement. TCP destination port can be determined by analyzing the second fragment only. Not so, it can be analyzed using any of the fragment. So the destination port will be available in both the fragments from R. This is also wrong. Once we know B is also wrong, we can say option 1 is also not there. Option number 2, A and C only will be the right answer. Next question, match list 1 with list 2. Physical layer. In the physical layer, the data will be in the form of bits and it has to be transmitted over some channel. So in this case, we will mark A23, transmission of raw bits over communication channel. Next one, data link layer. Here, the data will be in the form of frames. Transforming the raw bits in the form of frame for transmission. B is mapping to 1. A3B1. Option number 3 will be the right answer. Next, C. Network layer. Control and monitoring of subnet. Transport layer. Datagrams transmission data through connection oriented TCP or connectionless UDP using datagram. D is mapping to 4. Next question. Match list 1 with list 2. CDMA. It is code division multiple access. I have already given the full forms in the previous question paper, so I don't want to write it again here. What is CDMA? So it is accessing mechanism for multiple transmitters over a single channel. What is GSM? It is Global System for Mobile Communication. and it's a cellular technology that employs FDMA and TDMA. So B will be mapped to 4. A3, B4, we'll rule out 3 and 4 options. UMTS, Universal Mobile Telecommunications Service. This will be mapping to 1. It provides mobile internet connection with faster data transfer rates. C1 is here. So option number 2 will be the right answer. We'll also rule out option 1. Wi-Fi, wireless fidelity. It allows user to connect to a network or to other devices over wireless channel. It will be mapping to 2. Next question. The next 5 questions from here. It is based on the IP datagram. I have included the diagram of the IP header so that it will be easy for us to work with it. IP datagram has arrived with following partial information in the header in hexadecimal. Let's take hexadecimal is from 0 to 9 and 10 to 15 will be represented by A, B, C, D, E, F. How will you represent them in binary? Just take the last digit here. F is 15. How do you represent them in binary? We'll represent it as 1111. So we'll have 8421 and when you add up all this you will get 15. So this is 1 bit in binary. So how many bits do you actually need to represent one hex digit? So for one hex digit you will need 4 binary bits. Actually 4 bits, they are binary bits. Now they have given partial information in the header. Every number is a hexadecimal digit. Now we have to apply this hexadecimal digit and then interpret everything. Basically they are asking what is the header size. General IP header size will be 20 bytes. This is out of our knowledge. But here it is completely the header and hex len is nothing but header length. Understanding from this diagram, here it is 4 bits, 4 bits. So 8 bits, then 16 bits, there are 32 bits. 32 bits will make 4 bytes. So 4 into 8. Okay. So this row is 4 bytes. This is again 16 plus 13 plus 1 plus 1. This is again 4 bytes. This 8, 8 and 16. This is again 4 bytes. Source is 4 bytes and destination is 4 bytes. Till here if I take, it is 20 bytes altogether. I have to add up all these and say it is 20 bytes. Because here it is optional from 0 to 40 bytes. So an IP header can range from 20 bytes to 60 bytes. But we have to derive it from the IP datagram. I have to allocate every digit of the hexadecimal form to this IP header. This is for our depiction. This is for our eyes, for the humans to understand. But this information is understood by the system using this code. The version is given by 4 bits. So how many bits make up one hex digit? 4 bits. So the first hex digit 4 will represent the version. Then we have hlen is equal to 4. It means the next digit will represent the hlen field. So 5 is the length of the header. That's why 1, 2, 3, 4, 5. 5 into 4 will give you 20 bytes. This is how we have to calculate the header size from the IP datagram information. Option number 2, 20 bytes will be the right answer. 20 bytes is the header size. So for the subsequent questions, we'll just map the hexadecimal digits to the corresponding fields. Next question, what is the size of datagram? Datagram size is given by total length. This field. This will be the sum of data plus header. Datagram size will include the data value as well as the header value. Now how to find this total length? So as we discussed earlier, this is 4 bits. So the first digit is represented here. Then for the next 4 bits, the next hexadecimal digit. Now it is 8 bits. 8 bits means it is 4 bits and 4 bits. This is the first hex digit means this is the second hex digit. So 4 and 4 will have 8 bits means you have to take 2 hex digits. So what are the next 2 digits? 0 and 0. Then we have 16 bits. 16 bits will take 4 hexadecimal digits. 0054. Now this is in the form of hexadecimal. If you convert this into decimal, you will get the total length, that is the datagram size. How to convert this into decimal? You have to add the 16 parts together. So let's start. 4 into 16 power 0 plus 5 into 16 power 1 plus 0 into 16 power 2 plus 0 into 16 power 3. Okay, so this first 2 will give 0, and this is 5 into 16 power 1 is 16, 5 into 16 is 80, 4 into 16 power 0 is 1, so 4 into 1 is 4. So 0054 in hexadecimal is converted to 84 in decimal. Therefore, the datagram size will be 84 bytes. So we know header is equal to 20 bytes, and so data will have the remaining bytes. Okay. What is the size of the datagram? 84 bytes. Option number 3 will be the right answer. Next question. How many more routers can the packet travel to? The time to live field will tell you about it. Let's interpret again. This is 4, this is 5, this is 00, and this is 0054. Next we have 16 bits. So we will mark 0003. The next 4 hexadecimal digits. So 16 bits is equal to 4 hex digits. And next we have 1 plus 1 plus 1 plus 13. All together we have 16 bits. So we can take 4 hexadecimal digit. 1, 2, 3, 4. So together I am taking 0000. Now time to live is 8 bits. So 8 bits means 2 hex digits. It is 20. 20 is in hexadecimal format. Convert it to decimal. 2 into 16 power 1 plus 0 into 16 power 0. 2 into 16 plus 0. 2 into 16 is 32. Option number 4, 32 will be the right answer. We can say it needs 32 routers, or it will have 32 hops. Next question. What is the protocol of the payload being carried by the packet? So the protocol field will tell you about it. So we have seen the interpretation till 20. So let's mark 4, 5, 00, 0054. Then we have 0003, then we have 4 zeros, we have 20. Now the last 2 hexadecimal digits given here, 06. The question says it is only with partial information. That's why they have stopped. If you browse in the web, you will see the complete IP datagram, and there will be lots of questions regarding that. What is actually payload? Payload is your data, okay, or payload is what it carries. So the protocol of the payload is given in the protocol field. It is 8 bits actually. It means it will take 2 hex digits. So protocol has the number 06 in hexadecimal. You have to find the decimal value of 06. 0 into 16 power 1 plus 6 into 16 power 0. So 0 plus 6 into 1, which is equal to 6. So you have the protocol value as 6 in decimal. There is a website called iana.org. What is IANA? Internet Assigned Numbers Authority. If you go to their website, there will be a list of numbers and their respective protocols. The protocol number 6 is for TCP, Transmission Control Protocol. Option number 3, TCP protocol, will be the right answer. So for information purpose, let me give you the protocol numbers of the other 3 protocols that are in the option. What is ICMP? It is Internet Control Message Protocol. ICMP has the protocol number 1. SCTP, it is Stream Control Transmission Protocol. The protocol number of SCTP will be 132, and TCP it is 6. IGMP, Internet Group Management Protocol. This has the protocol number 2. You can note down the protocol numbers of some commonly used or frequently asked protocols. Next question, what is the efficiency of this datagram? Efficiency is given by the formula payload divided by total length. Payload is nothing but the size of the data and total length is data plus header size. Already we have calculated the total length as 84 bytes, and from the first of these 5 questions we know the header size is equal to 20 bytes. So this is like 84, this is 20, and we have to find this x. Okay, so how much is the data size? 84 minus 20, data is equal to 64. This data size is the payload size. Now I should substitute 64 in place of payload, and I'll substitute 84 in the place of total length. So efficiency is equal to 64 by 84. 4 16s are 64 and 4 21s are 84. 16 by 21 will give me 0.7619. To convert into percentage, I am multiplying it by 100. Now this will give me 76.19%. Option number 1 will be the right answer. With this we are completing Unit 9 questions. Let's discuss Unit 10 solutions, which is not the component of the natural language understanding process. So what is natural language understanding? It's a branch of artificial intelligence that uses software to understand input. This input will be in the form of sentences. So it understands input using text or speech. So there are some phases of natural language process. So let's start with lexical analysis phase. Then it goes to syntax analysis. Then semantic analysis. These 3 phases will be similar to compiler phases. From there we go to discourse integration. What is discourse integration in simple term? The meaning of a particular word or a line will be based on the previous line. Then we have pragmatic analysis. This is about interpretation. So these phases will be involved. Now they are asking which is not the component. So morphological analysis is equivalent to lexical analysis. So this phase is there. Semantic analysis is there. Pragmatic analysis is also there. Meaning analysis is not a phase in natural language understanding process. So option number 4 will be the right answer. Next question, which is not a basic approach to the problem of conflict resolution in production system? This content is from the topic rule-based system in artificial intelligence. So under this we have something called production system. What is a production system? It is actually based on a set of rules about behavior. These rules are a basic representation that are found helpful in expert systems, automated planning, and action selection. I can give you an example. If some condition is there, then this will be the action. When a new rule is added to the database, it should ensure that it does not have any conflict with the existing rule. In case if there is a conflict, then conflict resolution strategies will be there. What it is? It is to choose which production rule to fire. Under this topic, they have given a statement like the result of the matching process is a list of rules whose antecedents have matched the current state. So whenever it is in the current state, based on that, it will have a set of rules from which it can choose a particular action or a particular rule to fire up. So there are 3 basic approaches to conflict resolution. Since there are 3 basic approaches and there are 4 options given, definitely one option will not be a basic approach. So let's see what's the first approach. Assigning a preference based on the rule that matched. So first one is there. It is the first approach. Then the second one, assigning a preference based on the object that matched. This is the second basic approach. The third approach will be assigning a preference based on the action that the matched rule would perform. So there are totally three basic approaches and all the three are listed in statement 1, statement 2 and statement 3. So option number 4 will be the right answer. This is not a basic approach to the problem of conflict resolution in a production system. So what is it? Assigning a preference based on action that the matched object should perform. No, it is the action that the matched rule should perform. That's why in the starting I told you a statement. If you want, I can just write it for your information. The result of the matching process is a list of rules whose antecedents have matched the current state. So the preference is based on the rule that is matched or it is based on the object that is matched. That is the first 2 points. Then there is another preference. It is based on the action that the rule would perform. It is not about the action of the object because that object can react to different things. But based on the matched rule, the action should be there. Next question. Which of the following is not a property of a good system for representation of knowledge in a particular domain? So there are some properties for knowledge representation. The first one is representational accuracy. This is the ability to represent all kinds of required knowledge. The second one is inferential adequacy. This is the ability to manipulate in the sense to use the representational structures to produce new knowledge corresponding to existing structure. So we infer something and then produce something new. The third one will be inferential efficiency. This is the ability to direct the inferential knowledge mechanism into the most productive directions by storing appropriate guides. When I store those guidance, I can use it whenever that particular structure or that particular data comes or that particular system comes, I can use the stored ones. So they will say, even in a game, when this move is actually saving the player, that move can be stored. So whenever such scenario arises, we can use the stored rule. So such similar scenario is this. The fourth one will be acquisitional efficiency. This is the ability to acquire new knowledge easily using automatic methods. These are the 4 properties for knowledge representation. We have inferential adequacy, inferential efficiency, acquisitional efficiency. Option number 1, presentation adequacy is not a property. Actually, the only property that is left out is representational accuracy. So option 1 will be the right answer. Next question. Consider universe positive integer x is equal to, and proposition is n is an even integer and q is 3 less than or equal to n less than or equal to 7 and n is not equal to 6. So let's take x first. We have 1, 2, 3, 4, 5, 6, 7, 8. What is p? P is even integer. So n is even in the sense only even numbers will be taken. And what is q? Q is actually starting from 3 and ending with 7, but it should exclude 6. 3 to 7 and not 6. I am just writing it in normal word. Okay. The truth set of P by implication Q. P by implies Q is true when both P and Q are true and both P and Q are false. Whenever P and Q are true and whenever P and Q are false, this P by implies Q is true. So we have to find true cases of P, false cases of P, and similarly true cases for Q and false cases for Q, and then find where they go true at the same time. and where they go false at the same time. So this is for P and this is for Q. P is true when n is even. So I have to pick 2, 4, 6, 8 from x. P is false. N belongs to x only. So whenever n is not even, it is false. So 1, 3, 5, 7. Q is true when it is 3, 4, 5. I cannot place 6 here, though it is less than or equal to 7. It has been given that it is between 3 and 7 as well as it is not equal to 6. So I cannot include 6 here. I am just including 7 alone. It is false for the rest of the numbers when it is 1, when it is 2, when it is 6 and when it is 8. So when n is even, P I can say it is 2, 4, 6, 8. You can generally write this. And Q is 3 to 7 without 6. So 3, 4, 5, 7. This becomes the true case. Whatever number is missing inside will become the false case. This is what I have written here. P and Q when they are true. 2 is present in P but not in Q. Okay, let's leave it. 4 is present in P and 4 is present in Q. So it is true for 4 and 6 is not found here, 8 is not found in Q and 5 and 7 are not found in P. So in this case I can say P and Q are true in 4. Where are P and Q false together? One is present in false of P and one is present in false of Q. So I can include 1 here. 3 is in P but not in Q. 5 is in P but not in Q. 7 is in P but not in Q. Similarly, 2, 6, 8 are present in Q but not in P. So we'll include only 1 from this false set. P and Q are true for 4. P and Q are false for 1. Now the truth set of P by implies Q will be 1, 4. Option number 1 will be the right answer. Next question. Which of the following is not a solution representation in genetic algorithm? This solution representation will be under the topic genotype representation. There are 4 representations. The first one is binary representation. So if you take an example, everything will be in the form of binary. The next representation will be real valued representation. This will have real numbers 0.1, 0.3, 0.9, 0.6, 0.4, 0.2, 0.1, 0.3. The third representation will be integer representation. So this will be in the form of integers 2, 3, 4, 3, 4, 2, 1. Then the fourth one will be permutation representation. The solution is represented by order of elements. Say for example, let's take the traveling salesman problem. At the end, if I give you an ordering of all cities, the problem has 8 cities. Now I am giving the order of cities as the solution. 1, 5, 3, 2, 4, 6, 7, 0. If I am giving such an order, then this traveling salesman problem solution is in the form of permutation representation. The permutation of cities, or we say the ordering of cities. The numbers represent the cities. So these are the 4 representations. Let's check the options. Binary valued is there, real valued is there, permutation is also there. There is no representation called combinations representation. So option number 4 will be the right answer. Next question. Given below are 2 statements. One is labeled as assertion and the other is labeled as reason. Assertion. Dendral is an expert system. Yes, it is an expert system. In fact, the first expert system. This automated decision-making process and problem-solving behavior. This project consisted 2 main programs. One is called heuristic dendral and the other is metadendral. They say this heuristic dendral is called today as dendral. Assertion is true. Let's check for the reason. The rationality of an agent is not related to its reaction to the environment. Agent's action depends on various factors like the state of the environment, the time step it has reached, etc. The action is based on the preference of the agent. Whatever the agent prefers to do at that time, whether it has to react to the environment or based on the time it has reached, how the reaction can be, everything will be based on the preference of the agent. So when they say the rationality of an agent is not related to its reaction to the environment, it has to react to the environment. Agent has to respond to everything that happens in the environment. The state of the environment can alter the action of the agent. So it plays a role and it has a relation to it. In that case, we mark reason to be false. So A is true but R is false. Option number 3 will be the right answer. Since R is false, there is no question of whether it's a correct explanation or not. Next question. Given below are two statements. Let's take the fuzzy system components. Here we have a fuzzifier. Then here we have a defuzzifier. Here we have inference engine. Here we have the rule base or the rules. So basically there will be some crisp input. This will be sent to the fuzzifier and this fuzzifier converts the crisp input to fuzzy input and it will be sent to the inference engine. This inference engine applies rules to knowledge base to deduce new information. This is the work of inference engine. So when I say it applies rules to knowledge base, these rules will be or the rule base will be connected here. So once it deduces information, it sends the fuzzy output to the defuzzifier. From here we get the crisp output. So the fuzzy output will be converted to the crisp output by the defuzzifier. Fuzzifier will convert crisp to fuzzy input. These are the different components. I have just given them in rectangular boxes. They are the components, but they all belong to the fuzzy system. So fuzzifier is a part of fuzzy system is true. Inference engine is a part of fuzzy system is also true. Option number 1, both statement 1 and statement 2 are correct will be the right answer. Next question, which of the following is not a mutation operator in genetic algorithm? So what is mutation operator? It is used to avoid local minimum by preventing population becoming too similar to each other, thus slowing or stopping convergence to global optimum. So there are 5 mutation operators. Let's see one by one. First one is bit flip. So I am just giving 4 values alone. What will bit flip to? If I want to flip this particular bit, then this becomes 0, 0, 1, 0. So I have flipped this bit. Only one bit will be flipped there. Then we have random resetting. So I can flip a value based on random choice. The next one will be swap. I have to swap the values based on the positions. Say for example, if I have 1, 2, 3, 4. Then if I want to swap these two, then it will end up like 1, 3, 2, 4. Then we have scramble. When I have 0, 1, 2, 3, 4, 5. This will scramble certain positions. Say for example, from here till here I want to scramble it. It will become like 0 and 5 will be there. These positions will be disturbed. The arrangement will be scrambled or the arrangement will be altered. So it can be 4, it can be 1, it can be 2 and it can be 3. Next we have inversion. This will actually inverse those selection. In scramble we selected these 4. In scramble it has altered positions, but in inversion what will happen is 0 and 5 will stay and the inverse of this set will happen like 4, 3, 2, 1. Here it is scrambled order, here it is inverted order. And swap is just altering 2 positions. Random resetting is just flipping any position. And bit flip is just turning any one bit to the complement, like 1 becoming 0 or 0 becoming 1. Now let's check which is not a mutation operator. Random resetting is there, scramble is there, inversion is there. Difference is not a mutation operator. When A, B and C are mutation operators, we can rule out option 1, 2 and 3. D only will be the right answer. Next question, consider the following statements. C fuzzy means clustering is a supervised method of learning. Clustering is unsupervised learning. Clustering is not a part of supervised learning. But C fuzzy is a method used in clustering. That is true, but this part is not true. So A is false. Next statement, PCA, Principal Component Analysis. PCA is used for dimension reduction. Yes, it is true. We have a topic called dimensionality reduction and PCA will be the most commonly used method to do it. Next statement, a priori is not a supervised technique. A priori algorithm is an algorithm used in association rule mining. Association rule mining is in turn unsupervised learning. It is not a supervised technique is true. Not supervised in the sense it is unsupervised. Association rule mining is unsupervised technique and a priori algorithm is used for association rule mining. Next statement. When a machine learning model becomes so specially tuned to its exact input data that it fails to generalize to other similar data, it is called underfitting. There are two terms called underfitting and overfitting. When the model fits the training data perfectly and when it does not do well in test data, it is called overfitting. So this is what they say. It is tuned to its exact input data, which is the training data, and it fails to generalize to other similar data as the test data. This concept is actually overfitting. So D is false. Then what is underfitting? In underfitting, model does not learn any patterns even in the training phase. So we have A and D as false. Any option that involves A and D can be ruled out. Option number 2, B and C will be the right answer. Next question, match list 1 with list 2. So let's start with fuzzy system. We have just discussed about fuzzy system. Fuzzy system will map to inference engine. B is mapping to 3. The only option that has B3 is option number 3. So option number 3 will be the right answer. Next we will see operator in genetic algorithm. Scramble. C will be mapping to 2. Next, supervised technique. In supervised technique we have regression and classification, and under classification we have decision trees to be one of the algorithm. So supervised technique will map to decision tree, D to 1. And obviously the expert system will be option 4, mycin. So A is mapping to 4. What is mycin? This is a computer based consultation system. From the word consultation we can understand that it belongs to medicine field. This is to assist physicians in diagnosis and therapy selection for patients with bacterial infections. So mycin is an expert system. Option 3 will be the right answer. With this we are completing Unit 10 questions.